If I turn that up, no, I don't think that's the solution. What if I do that and actually plug the cable in? I bet that'll help. Okay, let's go with that. I'm going to talk a little loud. Okay, I'm peeking in the yellow on the mixer. So there we go. That should fix it. Yeah, plugging that cable in all the way makes a big difference. Let me catch up here. Hello, Helen Croft. Hello, Cobrian. Hello, Spies of Mud. Hello, Dutch Black Cat. Black Jam Alex. Commander Keen. Jout76. Lay84. Lady Ironborn. Hello, Juss. I'm going to go with that. Fox Camus. Tay-Tay. Man, a lot of people here. Moderate Vertigo. Large the 18th. I think that's everyone. Hello, special hello to Dreams at Grand Dragon, since it's your first time chatting. Yeah, okay. So, hello Hiram and Platypus with Cheese, and hello Evil Warthog. So, today's stream is going to be kind of interesting because I get to try out something that even when you know what you're talking about, people don't think you know what you're talking about. So that'll be fun. But a little announcement here first is that at some point here, we're going to be building a new stream computer now because I was sent some parts, and these are kind of amazing, and I'm very taken aback by these. Christmas came early, yeah, kind of. Also, hello, Calliope. Since it's first time chatting, and glad you're able to check out the stream too. Audio a little gainy. Oh man, I just can't get it right here. Let's turn it down a bit, and to the people who watch the YouTube VODs, my apologies. I don't know why it gets quiet, and it's not because I'm turning it down. I can see on my meters that it's peaking red, so That's what it is. Now, see, always watch your videos. Just found out you did live streams. Even better watching you live. That's cool. Anyway, what we have here is kind of absolutely perfect for what I want to do with streaming stuff. So first off, that's a 1080 Ti, and that will be amazing for doing live video encoding because that has the really good NVENC stuff. Maybe not as good as like the current generation, which I think is their second iteration on that hardware, but that's what I use for my video editing computer, and I am very happy with how it works out. So that's going to be perfect for streaming. The Lady Ironborn, thank you for the sub there and for the 4th month in a row. But it's not just the 1080 Ti. There is this, which I'm going to go ahead and set. Well, that'll work actually, and a couple of other things here. Whoa. Helen Croft, thank you for the 20 gifted subs. Holy moly. Whoa, thank you. Wow. Okay. That's incredibly generous. I really appreciate that. You're gonna make me feel a little guilty here about what I'm about to say with this stuff. So, okay, whoa. You guys are incredible. Thank you so much. Wow, Commander Keen, thank you for the 10 gifted subs. Did we just immediately do a level 5 hype train? Hold on. What? Maybe it was the UI. I don't know. Let me click the thing here. Level 5 complete, and it just started. Spies of Mud, thank you for the 100 bits. And BS Repellent, thank you for the 150 bits. You guys are amazing. Thank you so much. Okay, so let me get back to this. These are really incredible pieces of hardware here, a 1080 Ti, and then this is a motherboard box, but it is populated. Here. And it has a CPU. It's a very heavy motherboard. It has a CPU in it, and it is a Threadripper 2950X. So, with the capture card hardware I use, which is all PCIe based, Evil Warthog, I think it's going to treat me very well, and I'm extremely appreciative of this. Yeah, there's just one thing. Okay, so the hardware here is really, really good. And let me get out the 1080 Ti because it exemplifies this more so. Yeah, that's the thing, Platypus. Both of these parts were used in a water cooling system. So the graphics card is also water blocked. So if I actually, let me just switch over to this camera for a moment here. So this is the 1080 Ti, and that is the motherboard there with the massive solid, I think the top is brass and the bottom is copper, but both are nickel plated thing there from my research. So these are really awesome. There's just a couple of problems that I was not anticipating. One, if I can bring the camera all the way down here, this is the case I was gonna put this in, and this graphics card is literally physically taller than the computer case. So I'm not gonna be able to use the Silverstone rack mount case for this. So that's a thing. And then the HP Z820 that I have down here. The camera, oh my gosh, are you kidding me? I just crushed another micro HDMI adapter. There's the HP. Well, hold on, Hellencroft. It gets a little more complicated than that. Kind of a bummer you can't use the Silverstone case, but that hardware is impressive. Yes, the hardware is very impressive. Okay, so I can't even go with that. Let's go with this. The HP Z820's case can't be used either. I actually don't own a computer case that isn't in use that's thick enough to hold that card because it sticks out so much. And then water cooling, I've never done before. I don't own any existing hardware for this. Blackhawk92, thank you for the sub and for the 3rd month in a row. I said I was really excited to try water cooling, and I am. I think that's going to be a lot of fun, especially we'll probably build this on stream, which will be really cool to see. But I did not know quite how expensive water cooling hardware was when I was saying that would be really fun to do. And I put together everything that I would need to do a water cooling setup for this system, and it was a lot more than I was expecting to do. So I'm just going to say for right now, this is going to have to be, well, I'll run the SL there. Hype train is completed. You guys are amazing. Thank you so much. Just wow. Yeah. The cost for the water cooling stuff was a little more than I was anticipating. So I'm gonna have to be putting this off for a little bit of time here, but I've put everything that I need for the water cooling setup in the Amazon wish list. So I'm gonna just do that really quick. And if you want to help, if that'll work. Did I misspell it? No, I don't know. There we go. So you can see everything there that I'm going to need to get for this. And I've tried to figure out everything, but it's going to take me a little bit of time to get all of the parts to put this system together, which I was not expecting. So we have the stuff. It's just going to take me some time to get the parts because I'm already kind of budgeted out for a while right now. I have to get the new camera that we're getting incredibly close to. Because that the goal there only covers half the camera, and then I'm doing the other half from YouTube money. So I'm like putting the 2 funding sources together. So and then I have a capture card that I need to buy so that I can stop having to rely on these USB ones that are not good. So my budget for this kind of stuff is stretched out for a while. So if you want to help make this happen quicker, you can look in the Amazon wish list, and if there's anything you can get that would make this happen faster, and I would be extremely appreciative. But yeah, no pressure. I'm just saying if you want to do that. So yes, eventually we will have a really nice streaming system. It's just a little ways away, but I'm extremely grateful of this stuff because this is going to be amazing for a streaming computer. So I'm really looking forward to it. So there we go. That's just all I wanted to cover first here. And you guys really blew me away there with the, wow, yeah. Try to get a pump reservoir combos. They can be a bit cheaper. So what I was seeing was that there was a Thermaltake one and a Corsair one. Oh, here's the other thing. These are both EK water blocks. They're both nickel-plated copper and brass. And I want to make sure that I stick within copper and don't go with aluminum anything. And I couldn't tell what the metals are in the Thermaltake and Corsair water pumps and reservoir stuff. So if they don't say what the material is, I assume it's aluminum because aluminum's a lot cheaper and there's a lot of aluminum water cooling stuff too. So there's that. And then the actual reservoir I got, plus the water pump that I picked out, I think comes out to about the same cost as most of the reservoir pump combos from at least the brands that'll tell you like what the stuff is made out of. So yeah, I think that one that I have, or the hardware that I have in there is representative or is reasonable, but I don't know. I've never done water cooling stuff before, so all of it's new to me, and I know I'm just trying to check metallurgy compatibility and going with parts that are going to be reliable long term, because this is going to be a streaming computer. So it's going to be kind of one of those things where I just need to turn it on and work. So yeah, the iOD is out of stock. I'm not sure that it'll be there ever again, because it's kind of an unusual piece of hardware, and I don't know if it'll show up again. So, but this did come with memory, so I don't need that. And then the power supply we're using to test the PC 104 system, I'm actually going to put in this system, so I don't need that. Storage, I'm just going to pull one of the SATA SSDs from the HP Z820 and use that in there for now. And then I actually have hard drives that I'm going to put in this. I was planning on building up the second Supermicro board as a sort of server to run while I'm here, that would have copies of the old computer data sets that I keep around, like drivers, manuals, software, disk images, all that kind of stuff. You'll notice that it's been kind of annoying every time that I need something like that, as I have to go download it from the internet. Normally I have all that accessible, but since that was very bad, I'll get to that in a moment. Normally I have all that stuff accessible, but when I'm at the office, my server's really far away and my connection to it's terrible. So yeah, Calliope, I went with AlphaCool because they say that the radiators are actually made of copper. So that's part of why I went with them. But they do seem to be very reputable. Now I have a mess to clean up down here, and I'm very sad about that mess, but very glad I film everything, because the screws for the CompuPro floppy drive all just fell out of the retainer thing I had there. So that's fun. I'm working a little too quickly here, but if I might as well turn this on because I have to clean that up too. So yeah, the Lady Ironborn. Whoa, COVID fever brain dictates I send you some bits. Thank you for the 5,000 bits. Whoa, that's awesome. Thank you. Holy moly. I really appreciate that. Oh yeah, this. Wow, okay. So, can I, this just happened down here. I can turn this light on at least. The GoPro's kind of done, but yeah, now I gotta go clean this up here for a moment, because well, there's the HP computer I was trying to show you a moment ago. But anyway, that pillbox there has all of the screws that I took out of the CompuPro floppy drive, and the top fell off when it fell down there, so now they're all mixed up. So I don't know where they go, and I'm probably gonna have to review the video to figure out what goes where, so that's fun. I'm just gonna put them all back in there together for now, and then I'll try and watch the stream and sort those out so I can see which ones went where in the power supply. I suspect all the black ones actually are the external ones, so maybe I can separate those. So I think those are the ones that are used to hold the top onto the case. Oh man, wasn't expecting to do this here. I think that's, well, there's a couple more washers for the external case screws. Go there, and then everything else should be either the screws that held the power supply chassis to the case, or the ones that were beside the, oh, of course I put them in the one that was missing the thing, or the screws that were holding down the power supply internally, either to the bottom plate or the back. So, okay. There we go. Oh, that's fun. All right. COVID sucks. Somehow I've managed to avoid it. Yeah, I've managed to avoid it so far. What's the virtual camera system focusing on? I have no idea. I couldn't see the screen at all. Okay. Oh man, all right. Let me see if I have another micro HDMI cable adapter thing here really quick. I think I have one that's in a package I haven't opened yet. I'm almost a little afraid to. I have the, like, Sid from Toy Story feeling here where I'm just gonna destroy it immediately. I have them connected with strain relief on there. It's just that the cables are right, actually here, you can see the GoPro. See how dumb this is. So this is the GoPro and the camera is loose. The cables, let me just go to manual focus, connect right here on the very edge of the camera, and it is so easy to accidentally bump and bend them over, and that micro HDMI one just snaps constantly on me. So that's why that has happened multiple times now. There should be another cable over here, I believe. I really thought there was. Or maybe not. There should be, but I don't know. Let me go check my camera supplies bin. Maybe I moved it over there instead of just leaving it piled up over here. Let me do this. Let's go back to here. I will be back in a moment. That's Nikon cable, T-slot mount. That's not it. Okay. Well, I have one other option. Somewhere down here, I believe, there's an HDMI joiner. Where did that go? Or did I chuck it into my HDMI cable bin? If it's down here, it's on this cable. And where's the end of this cable? It loops around, goes over to the laptop. So it's not there. Okay, I think I know where the HDMI joiner is. I just have to walk out of frame for a little bit, dig in this bin, be disappointed I don't see it. Really? Okay, that's all right. I found a splitter that might actually work. Okay, the other thing I have, and I'm a little concerned about trashing this, is an HDMI micro cable. This is a whole cable for this. And I might be able to put it into this HDMI splitter and have that work. I don't know if it's going to be enough power to get this to turn on. Let's see if that'll work at all. I'm just going to have a million cables around here. Ah, it did work. Okay. Oh boy. That's a lot of cable. Just wrap that around there. Okay. All right, let me catch up here again. So I was just watching a VOD on YouTube. Nice to catch you live. Ah, cool. I have not had the opportunity to catch up on the VODs in a while. I've been doing so much other work, and then by the time I think I should start working on the VODs, it's like really late, and I want to just tune out. I've been trying to really make sure that I take breaks recently, and that capture card. What? Wait a minute. Whoa. Okay. Wow. Whoever bought the Blackmagic Decklink Quad HDMI, thank you tremendously. Whoa. That is going to be a huge thing. Wow, that is massively helpful. Thank you. Holy moly. Okay, I really appreciate that. That is incredibly generous. Thank you. Yeah. Wow. Okay. I was not expecting that. All right. So the benefit to that card for me needs to be an unboxing on stream. It absolutely will be. That is a very, very good piece of hardware. And yeah, wow, okay. So here's the deal. Here's why that card. Let me, and especially with this system, let me talk about how those two are going to work together here. These capture cards that I'm using, okay, the USB ones, all right, even the game cap USB are MJPEG cards or similar to that, where they compress the video signal before it's actually sent to the computer, and it results in a loss of video quality before OBS even starts processing it. The Nikon here, part of why it looks so good when it's working, like if you see that video looks way, way better than this video does. And part of that is because this camera is going through a Blackmagic Intensity Pro non-4K. The camera, I have the Blackmagic actual camera, this camera is a Blackmagic Intensity Pro 4K, and those are the only two good quality capture cards I've ever been able to get. And I have to use those for those cameras basically because the Nikon outputs 1080i, and the Blackmagic capture card is the only one I have that I think will normally capture that correctly. But also when I'm using it, I want it to be quality footage, and then that camera has to be connected to it, to that, because we zoom in so much that the video quality would be really, really bad if I don't connect that. So the quad Blackmagic capture card is going to allow me to ditch the USB webcam and replace it with another better camera, and then the GoPro here actually outputs better video quality than you can get here, and we will be able to see that with the Blackmagic capture card that will give this the full experience. And the other real benefit to all of that is then the quality of the video that will be recorded will be the absolute best it can be for 1080p, which means that when I edit streams into videos, the only downside to that over my normal video workflow is that it will be 1080p. And that is going to be really awesome, because normally those videos look kind of terrible because of the low bitrate video capture devices and everything. So that's a really big step towards the streaming becoming a significant part of my normal video creation process, making it easier for me to stream and make YouTube videos at the same time. So I really appreciate that. Thank you so much. Wow, okay. Wow, we haven't even gotten into the actual stream subject here. Whoa, okay, let's let me get to that here. I need to look a thing up here really quick for this, I think, actually. Where I may have the stuff. Actually, it's hosted. I can just look at it on archive.org. That's right. I need to bring up the manual for the power supply here. Hold on. Interlace is still used. I thought it was extinct. This camera is from 2015, so it's a little old. And then it's not really meant to be used like this. Actually, I should turn the sensor off while it's not actually actively being used. So it's kind of weird in that it only outputs that. So yeah, it's a kind of a flaw for it. It really does suck. So yeah, yes. Wow. Okay. Let me find the, keyboard, really. We're gonna go to the GPIB code here, because I have this linked there. So my HP 6633A here. Okay, so Leia, we'll do this. I have a fun keyboard picked out, but I do want to warn you in advance. I'm not going to be using the keyboard a lot in this stream, most likely, but we will change it out. So I was using my Keychron K8, which I also realized the other day that the glue on one of the feet has completely let go. So now I'm going to get to glue that back on. This thing has just been a disappointment all around. We're swapping out the Keychron K8, which was a not good keyboard, with a keyboard that's also a keyboard. The Creative Prada keys here. Which, if you have not seen, it is exactly what it looks like. It is one of the most ridiculous keyboards I own. Let me get this thing up here so you can see this in its full glory. This keyboard is both a PC computer keyboard and a MIDI controller. Now, the MIDI controller part is only done through USB, so it's not like it has actual MIDI outputs that I could connect like to a sound canvas or something. But this is an actual keyboard, and it works okay. It's not tremendous. Neither is the typing experience of this thing. But how many keyboards have both of these? Not a lot. I do actually have a video about this that you can watch if you want to learn more about this and how well it works. But yeah, this thing is pretty hilarious and amazing. And thankfully, it comes with a wrist rest, so you don't have to constantly be resting on those. So we won't actually be using that in this stream, because that's like a whole other thing and why I made the video about it. But yeah, that is what this is. It is genuinely a music keyboard and a typing keyboard all in one. It's hilarious. This is actually the latest version of this. They have one that's PS2, and I think the MIDI keyboard aspect still goes over the PS2 connector, and then the software driver converts the extra like scan codes that are on this into like MPU 401 software MIDI. But this thing actually shows up, I'm not sure quite how it works, there might be like a hub controller in here. It shows up as a USB MIDI controller and a normal USB keyboard, so it's both in one, which means it just works with stuff like Linux. It's really awesome. So, yes. Spies of Mud, thank you for linking that. Yeah, but you laugh, but this is something for like perfect for a composer working in a small space. Tater's Games, that is exactly why it's great. It is really awesome. The only way it's weird though. It's velocity sensitive, but it's very unpredictable. The way that, I almost wish it wasn't velocity sensitive, or maybe in your software you could configure to disable that, because it's kind of better for doing like sequenced compositions where you want to just quickly put in like a pattern. Like if you wanted to type in the notes that you wanted to hit, this would be great for like, I want it to be this, and then like say this, and then that. It's not great at actual performance recording, but for just having a quick access to a music note input device, it's really great for that. So yeah. So keyboard is a composite USB device? Okay. So yes, it is, it's pretty hilarious. But yeah, I'm glad I picked this keyboard intentionally for today, because we're not going to be typing a whole lot. So that is why I went with that one. So though I do need to use the computer for a little bit here, because we're now going to be taking a look at this. See, Pharrellian, thank you for the 500 bits. I really appreciate that. So okay, this is the manual that is for both the 6633A that I have down here, well, up on the workbench, and it's for the 6632A that I have sitting on the floor that we took a look at. That's the one that has the banana jacks on the front. And if we look a couple pages into this power supply, we're actually going to be going to section 4 here, output connections and operating details. If we go into this, we will see how this power supply functions. And under output characteristics here, we will see, not in there, okay, the operating locus figure 4.1 shows a single range 2-quadrant capability. This means that the power supply is capable of sourcing as well as sinking current over the output voltage range from 0 to the rated maximum. So, what this is this is a graph that displays the range in which this power supply can function. Now, a normal power supply operates in this quadrant only. So this is actually a quadrant here. The upper left or upper right quadrant is both positive axes, where current is the x-axis and voltage is the y-axis. Most power supplies can only do positive and negative, or positive current and positive voltage, so they are only there. This power supply can do negative current, which means that it can operate over here as well. So this is negative X or negative current in this instance. Now, this graph here is showing that it can operate at full current in negative, which means that it can sink the full rated power of the power supply directly into it. So it will dissipate that power as heat. What this really means is that this thing is both a power supply and a load tester in one unit. And this works on the principle that a MOSFET, a power FET, can be used to sink current and dissipate it as heat, because it just works kind of in the opposite direction as sourcing current from it. So that's how this setup works. Now, not all power supplies are like this, and not all of them work in quite the same way either. Over here, if we go back to clickety click click. Oh, I'm in. There we go. If I go over here, and you know what? This is a job for the GoPro. And I show you this power supply. Hi. Extra cables now. This is my HP 6624A. Now, this is a quad output power supply. It has a high range and a low range, and I need to disable the user interface on this thing again. Oh, there's my water. I'm going to grab that. So the two ranges on this can actually operate in 3 quadrants. It can source and sink current, but it can also do negative voltage, but only negative voltage with positive current. It can't do positive and negative voltage. So it's not a 4-quadrant power supply, but it is a 3-quadrant power supply. So that means that between the two 6630 series and then this one 6620 series, I can actually sync sources from up to 4 to 6 total voltage rails, which is kind of amazing and going to make it so that I can do some really intriguing testing eventually, especially with something like this, an ATX power supply that has an Ethernet cable on it, where we will have positive 5 volts and positive 12 volts as well as negative 12 volts. That means that I could load test this power supply exclusively with actively programmable sources. Asterisk. There's one downside to this power supply. The 6633 that we're going to take a look at today limits the current sinking based on the setting on the unit. So like we were setting it to between well, actually up to like 10 milliamps when we were doing capacitor reforming. So if it was set like that, it would only draw 10 milliamps from the device. This does not have any current sinking limit capabilities. So we'll have to be very careful when we use this to do any kind of current sinking or load testing, because it could go bad. So this one is not as ideal for that, but the other two are really good. So, okay, that's what I'm working on. Yeah. See, that heavily stabilized video straight out of the cam is so unreal. Are you talking about the camera here that I'm now boxed in, where I like move over and then it slides over like that? Is that what you're talking about, Nick the Dusky? Also, hello, since it's your first time chatting. So, let's see. Remember to turn off the Nikon. Yeah. Let me do that. Thank you. Put a fuse in series. OLN, I will probably have to do. Oh yeah, we should switch over to that. I probably will put a fuse in there or a breaker or something. Once I figure out the current limit's kind of low. Oh, you meant the GoPro or this thing? Oh, okay. When I was moving it around. Okay, yeah, it does do that. Now I think about it. I thought I had that disabled, but oh well. But yeah, it will do that, which is kind of good because the arm is a little wobbly. So now I think about it, probably should leave that on. But yeah, it's kind of nice for that. So yes, but today we're going to be trying out the 6633 I have here, which is interesting because when I turn it on, you'll see it'll probably show a negative voltage. Yeah, negative 7 or 0.7 microamps negative current. And that's just like a calculation error. It's not really, it's not generating current or sinking current from the air. But what that really shows is that it can go negative. That's why it's showing that. It's funny though, because we were getting readings that were negative when we were doing the capacitor reforming, because the values that we were sourcing from it were so low that it was rounding to negative when we were trying to discard that to make it work normally. But in this case, we're actually going to be using that. Now, to do this, I have another power supply that we're going to use here. That I haven't used in a while. This is a BK Precision 1711, and this is a linear power supply, which I do recommend having on hand because this is going to output much more stable voltages than the programmable power supply, because that one's technically switch mode. So I like having this on hand. It will buzz when you turn it on, because it's got a gigantic transformer. It's basically just a huge transformer in there. And the lacquer is starting to delaminate on that, making the plates kind of rattle against each other a little bit. So there's that, but it works well for this. So Olan, did you try reforming the big soda can capacitors yet? Not yet. I want to load test the power supply for the floppy drive first, so that we can wrap that up in a nice self-contained bow of I did the reforming, I did the testing, and now it works. And then we're gonna move on to the CompuPro. That's my plan. So this is a step in the direction towards reforming caps in the CompuPro, because I know I can buy those. So if it all goes totally wrong, I can actually get those and replace them. So yes. You know what? Gakro, I'm not quite sure how to pronounce it. I didn't mention hello to you as well, since it's your first time chatting. Oh. Yes, I anticipate it taking a tremendously long time to reform the CompuPro caps that are literally 100,000 microfarads. So, yeah, that's going to take some time. Now, let me move this out of the way here. One of the cool things about the BK Precision I have here is that this is a 0 to 60 volt power supply at 0 to 2 amps, which is very close to the 0 to 50 volts and 0 to 2 amps on this thing. So as long as I don't turn the voltage on the BK Precision all the way up, it'll be good. And this thing, which, did it come unplugged slightly, or is there just not enough current going on? What's the deal? Why is this not working? This is a RC car voltmeter that is supposed to work. Did I toast it with a voltage that's too high? Is that what just happened? I never considered that. So this is supposed to display a voltage on on it, but now I'm wondering what the voltage max is and if I just went over it. That might be, oh, there it turned on briefly. Okay, maybe it was just a bad connection. Let me turn this back off here and then I'll check on the messages. Just want to demonstrate this because you guys aren't going to be able to see the meter display on here. That's one of the cool things about this is it has meters, but on the other hand, it has meters. So it's kind of like, you can't tell, and then it's not like super well calibrated. There we go. Okay, so this is just connected to the voltage output, and we can see, there we go. The voltage I get a digital readout of the voltage on here now, which is really handy for video purposes. So there we go. Dr. Gecko, hello, Tech Tangents. First stream we've been able to watch. Ah, cool. Do you know that you can run multiple CPUs in the CompuPro? So do you mean on like one card? Because it has like the 8885 card, or do you mean multiple CPU cards in the system? Because it could be two things, I'm not sure. See, Hellcroft, 0.1 farads, yes. Yeah, kind of bananas. Okay, so doing this should be pretty simple here. Multiple cards. Well, that could be interesting. One moment. Okay, where is it? I should maybe not just wander off all the time. There we go. Oh my gosh, I have a lot of stuff. Holy moly. Whoa, I have more stuff than I realized. Wow, okay. CompuPro is buried, but you know what? It doesn't even matter. I was gonna... Oh, you could kind of see me. That was okay. So the CompuPro has the 8885 card in it, but I also have a 286 card that I could put in it, so we could try running in 8286. And then I have a CPU Z card that has a Zilog Z80 on it. And then I have an SPU Z card, which has a different Z80 and configuration on it. So that's another thing. So we could theoretically run 4 CPU cards in that CompuPro. So if we could run multiple cards in there, it might get really interesting. And for giggles, we could chuck the second MSI 8080 card in there. But of course, we're gonna have to figure out what it can actually do. So that's a whole other thing, and does it work? That one's kind of critical too. So, ND Threadripper card, yeah. I'll be able to bridge over the LJ775 ISA backplane card I have into the CompuPro. Oh man. See, can it run both x86 and Z80 processors at the same time? I bet it can. I really suspect it can, but I haven't. I have a lot of research I need to do. Unfortunately, excuse me. Oh man, I didn't catch you guys. Okay, we're doing another tangent here on stuff. We're not getting to this yet, which is fine. This is gonna. Let's just here really quick. So we take the leads from the power supply here, we plug them in here, all right. We turn this thing, what is this? That's on, this is on. Okay, we can see this is syncing there. If we turn this up, or the voltage up, we can see we're getting 15 volts there. I'm gonna turn the output off. Yeah, so we are not outputting there. I can increase the current here, and we're syncing power. There we go. we're sinking power. That's basically all we're gonna do. So okay, we sunk power. Okay, we're done. Stream's over. No, I'm gonna do some more other real stuff here. I'm gonna load down some things and see what it does. Although that is the load. I don't know. I have to learn. There's more to this, so we're gonna experiment with that. But that's basically what we're gonna do. So we were looking at the documentation. You know, this stuff. All right. Since I was last on stream, the only thing I have done is work through every single document that I scanned and compiled a list of all of them and which ones are scanned and which ones are not. So I present to you, me missing the click that I wanted to click, the master list of all of my documentation sorted by priority of the historical significance and whether or not there are existing scans. So if we scroll over here, on the right side you'll see there's one link there. That is the only document up top here that has a partial scan. This is I rated as a similar scan here. It's not complete, and I'm not 100% sure that it matches mine because I did most of this research at home and I didn't have all the manuals with me, so I couldn't confirm them. But all of these manuals that have nothing in these cells over here have no scans, and any of them that do not have a scan in this first column have no exact matching scan. So either have something that's a different revision or just a similar manual, or maybe my manual's more complete. So all of those I'm definitely going to have to scan as being new documentation that is going to be preserved, that has not yet been preserved. And there are, I hid it here, 47 of those. So there are 47 manuals that I'm going to have to scan that do not have any existing scans at all. And I now know this. And I also know, if I go back to that big manual here, something else that is really, really interesting. Let's not do that. Let's do this. Which side? Was it this side? Okay. Where was it? Yeah, MZI 8K basic, that's nice. Where is it here? This, okay, this document. This is one that we took a look at, and I said, oh, that could be interesting and potentially significant. So this, if I turn the camera actually on here, so this document is talking about a new basic Ender Killer 7500. We're taking a look right now. We're off topic of what the actual video is. We're taking a look at some documentation I have that I've looked over. So this thing is not just talking about some kind of basic that is being offered to the users here. What this is talking about is, I have it somewhere, the full documentation, wherever it went. Is it this? I think it's this. Here we go. This is talking about down here, basic E, right here. That is what the people who got this were being offered. And this manual for basic E, which is how you program in basic E, and it is a very comprehensive and long, complete manual, has not been backed up at all. So this is a programming language where the documentation for how to use the programming language has not been archived anywhere. So this is priority number one for me. That is the first thing I want to get backed up. So there is stuff in here that is genuinely significant, and I'm now hoping that I will go through the disks I have and find the matching disk version, because in another note it talks about compiler version 2.1 and interpreter version 2.2, and interpreter version 2.2 has not been preserved as software. The compiler as 2.1 has been. The interpreter, I've only been able to find a copy of 2.3. So there is potential to have new data preserved that is historically significant. So let me catch back up here. Can we expect a TT-BBS running on the MSI once you get it working? Probably not. that'd be a lot of load to put on something like that. I don't know that I will ever be hosting, a BBS type thing. I've never used one personally, so it's not like something I have nostalgia for, and it seems like kind of a pain to use. So I don't know. Let's see. That would be nice to also have it running the running the BBS. Yeah, I don't know. We might do that as like a novelty, but not long term. So how is Basic E different from just Basic? It is the concept of the basic programming language has been around for a very long time. I think I have a manual from HP, either from the late 60s or super early 70s, that talks about HP Basic and how to program in that. The concept of Basic as a language has been around for a really long time, but there are different implementations of it. So there is IBM Basic, which is included in the BIOS of the PC, and I think the PC Junior, maybe not, but like the IBM 5150 has it. And then you have TRS-80 Basic, which is actually, I believe, licensed from Microsoft and then rebranded. IBM Basic might be as well, but I also wouldn't be surprised if they created their own. Commodore Basic actually has roots in Microsoft Basic, going back to the Commodore PET, but they heavily modified it themselves from there. They licensed it once and then did that. Apple's Basic was also derived from Microsoft Basic, but there are truly independent basics like HP Basic and Basic E, which eventually became C Basic, which is what those weird books were that I don't think I have over here. So E Basic is a progenitor to C Basic, which was a Z80 Basic alternative, because Microsoft Basic didn't really permeate that market. So this is an extremely early version of a basic that was meant for Z80 type processors and those kinds of things. So yeah. So let's see if it does, and we need to have a stream in the front panel. Yeah. So my day is going well under Killer, and thank you. So let's see. I think it'd be fun to try it out once as an experiment. Yeah. I've got 4K Basic for my Nova on paper tape. Oh, that sounds like a nightmare to load. I hope you have all the stuff for that and backed up. I don't know how you'd back up paper tape other than like reading it out over serial or something. So it's like the difference between C by Bell Labs and ZC. Yes, very similar. So see, have you ever heard of BBC Basic? I have not personally used that or actually heard of it, but I assume that it's on like the BBC Micro, which probably is an independent basic since it was developed in a completely different continent. So yeah, I can see that. Also, hello, Ascertainment, since it's your first time chatting. So anyway, back to this. There are a lot of things that I now know I need to back up. Some stuff that I'm surprised hasn't been backed up, like whatever the MSI SES2 card is, both revision 0 and revision 1 of the manuals that I have are not archived anywhere. And matter of fact, most of the manuals for the actual MSI peripherals, as far as the cards are concerned, have copyright dates that I can find. The existing scans have copyright dates from 2002, and I don't know why. It seems like they were updated for some reason and then released, and I don't know what's going on with that. So I need to get all of those scanned that I have and then upload them as original documents that are unmodified. The updates to it, whatever was done in 2002, might be helpful, but it's also really good to have the original documentation. So I need to do that too. So let's see. BBC Basic is very good. Yep. It's a nightmare to load because the paper tape drive is so slow. Yeah, probably. You don't want the reader pins to rip it. So yeah, I can see that. But we have a lot here that needs to be documented. Also, surprisingly, all the Microsoft stuff isn't really available online. I actually mentioned this, and then BitSavers commented on one of my Twitter posts saying that they don't have like a release form from Microsoft to put that stuff online. So I don't know if Microsoft is going after people for hosting old documents like Nintendo does for hosting old ROMs. But I'm going to be scanning and uploading all this stuff to archive.org, and we'll see what happens. So, because apparently all the Microsoft documentation that I really thought was just going to be covered already isn't. So we will be doing that too. So there's a lot of that in there. But yeah, there is a bunch of stuff that we're going to have to back up here. So this is going to be interesting to go through, because there's a lot of it stapled. Oh, the really cool thing here. The really cool thing. Oh yeah, you asked about that. I didn't hear back. Yeah, I don't know. I did see that comment there. I didn't know that was you. What was I getting to? Oh yeah. So the glue-bound books, like the NPM, the CPM manuals we were looking at, all of those that generally I would have to have the like split glass photography thing, are all scanned. Every single one of them, same exact revision. So I don't have to scan those because they are scanned. I could scan them to try and get like better copies or something like that. But another thing is, it turns out that since I would be using my camera here, even if I could perfectly frame like a standard manual here, this is 8.5 by 11 approximately, even if I could perfectly frame it in front of the camera, it's gonna be less than 600 DPI at best. So the scans on that really aren't gonna be that great, because this is a 6000 by 4000 resolution sensor. So ideally I don't have to do that, because it's not gonna look very good. So thankfully, out of everything that I've got there, only 3 glue-bound books are not scanned. So I don't have too much to do. So we might do some like really wonky setup where we use the glass and like wedge it and then just hold the book open and scan each page from there. Because they're not very big, and it's the 3 things are the Fujitsu hard drive manual, which is not critical because interestingly, yeah, 600 DPI is the lowest it's used for archiving. I agree. So I'm not really happy with this as an archiving solution. The Fujitsu hard drive manual, it's really kind of weird actually. I don't know if it's still over here easy to get to. This. Oh yeah, this. Actually, let's talk about this first. This manual. This is a printed out manual that I also have a bound version of. This one has some handwriting on it, and I assume somewhere in here there is more handwriting that goes over modifications for whatever the LSI version of this means. But this exact handwriting right there, like literally that handwriting, is backed up on BitSavers. Now, that BitSavers scan is from 2019, and there is no way that this document is only 3 years old. I would not believe it. The paper doesn't feel like the kind of modern paper we would use. The way that it's distressed and aged, I don't think it would be. And just the kind of printing it is really doesn't seem like it would only be 3 years old. So what I'm thinking is that this is actually a kind of hobbyist modified, or possibly even officially modified, but then unofficially distributed update to the manual. And then the printed version I have is actually D1 revision here, and it has like a different font printed in it. So what I'm thinking is that the glue-bound version of this manual I have, because that's one of the things that is not scanned, is really just this printout, but sort of officially bound. So it wouldn't be the worst thing if I didn't get to scanning that book. So, or if it takes me a long time and it's not that great, because it's kind of already scanned, because that's scanned and that scans fine. So there's that. Then the other 2 books are the CBasic software directory and the CBasic 86 third-party programming manuals. So these are programming manuals by not the original company who wrote the programming language, just someone who read their manual and then like reinterpreted it. So that's also not super critical to get backed up. I would like to get it backed up and archived and scanned, but it's not the most critical thing. So with what that means is that all of the documents that are actually important to get scanned can either be done on a flatbed or document feeder. So I will be doing that, which makes my life so much easier. So yes, that's that's a really nice revelation, and happened because I spent so much time going through all of the manuals and trying to source out which ones were scanned and which ones weren't. Completely changed how I'm going to do all of my scanning, which is a big relief. All right, let me catch back up here. Let's see. Let's see. The open source based Arduino reader tape project use optical sensors. Ooh, that's nice. See, IMSI is still technically around as some employees set up a company to continue the support of the computers. Oh, that's interesting. Is that Fisher thing? I think I saw you comment about that. Yeah, Fisher Fried's company was set up by 2 former employees of IMSI when the company went bankrupt to continue supporting computers and users as well as making new ones. Interesting. Okay. Well, that kind of makes sense because there was that name was at the bottom of the documentation from 2004, which was really weird. I couldn't figure out why, but that makes sense. So, see, I hate for a glue-bound manual to have its spine taken off to be scanned at archival quality, but I could imagine that it might be the only way to get that done, short of scanning on a flatbed. So, what I'm going to do is, unfortunately, I'm going to set up this camera, and I'm just going to shoot photos of each page through a pane of glass, holding it flat, and I'm just going to do it manually. For the ones that I do have to do that with. When I eventually get around to it, those are literally bottom rung, the last 3 things I'm going to scan. Because everything else is more important than those. So I'm not too concerned about it, but yeah, we will be getting to that at some point. But we will be doing either flatbed scanning, which is going to be a little complicated. I'm going to use the, let me switch to, let me click somewhere so this will actually switch. Boop. I'm going to use the scanner that I have right there. That is an ADF. I have another scanner that is the same form factor by Hewlett-Packard, who's the manufacturer of that one, that has a different lid. And I'm going to go to my storage unit, and I'm going to go grab that one. It's SCSI only, so it doesn't really work with modern systems, but I'm going to grab its lid and put it on that one so it has a proper backing to it, and then we'll use that to flatbed scan all the stuff like this that has staples. I will just remove the staples from these. I would rather not, but I don't have a better option, and that will make scanning this kind of stuff so much easier. So we're just going to remove the staples. Oh. I just found an addendum. 48 documents we have to scan. We will be removing staples and flatbed scanning everything that can't be run through a document feeder because I want to make sure I get it done right, and that'll be the best way to do it right. Unfortunately, my HP4C, which is I think actually big enough to scan a 2-page sheet all at once, doesn't work. I would really like to get it working, but I've tried multiple times, and I'm not going to try and make that a requirement for this. I assume it doesn't work for this, so yeah. But that's the plan. We got a lot of stuff to go through. I'm going to be going through and scanning every page I can on the IMSI binders, even though they're all mimeograph sheets that are stuck together. I'm going to try and figure out how to unstick them because there are so many extra things crammed in those that I think I missed at this point, that there's probably, like, I wouldn't be surprised if there's another 20 manuals or something in there that I need to scan. So we're just going to go ahead and assume that we have to scan all the binders from the IMSI stuff, and then I will figure out what are separate discrete manuals that the previous owner just kind of slid in there and which ones actually go with it. And looking around online, like I saw that I have 4 manuals that are all IMSI floppy disk system manual is what the front is called. Some other scans online have different titles on the front, like DOS-A/CPM user manual for floppy disk system. And I have manuals that look like that, but they don't have that on the cover. So I think I may have different manuals for the floppy disk stuff, which is just, oh man, weird and strange to wrap my head around. So we're just going to scan everything that's in those binders because I don't think there's any other way of sorting it all out without going through every single page. So yeah. But all right, I should drink some water because that was a lot of really quick talking there. Oh man, I've had a lot of news. It's been a really busy week so far. Like really, really busy with just that stuff. It's kind of crazy. You know, I'm reminded of something here. I want to thank Xbox TV 81, and I'm gonna guess Jay Wilder. Both of them did Prime subs in between the last stream and this stream, and I appreciate that. So, yes, I forgot about that at the beginning, but I wanted to remember to mention that. Okay. Water is good. Water is very, very good. Okay, let's get back to the power supply stuff. Well, because we were over an hour into this, we barely touched on that. Okay, clickety-click back in the correct place. Okay, so just catch back up. This is a power supply, is a linear power supply. It is going to source power into this HP 6633A, which is a 2-quadrant power supply capable of sinking current. And I want to actually attempt doing this. So I'm going to set this to, let's go with 10 volts, and I would like to set the current output, but doing that's slightly difficult. I'm going to go grab a 12-volt fan, actually, so we can use that to check load. So one moment. Fans aren't the best for load testing because they have weird inductance stuff going on that can kind of change things, but for something like this, they'll be okay, because all I want to do here is really quickly give it some power. This is 5 or 14 volts. So this is a variable voltage fan that can take how many? A lot of power. this thing will have all the power. Let's see. Nearly done with my Nova service data sheets. Thankfully, it was only 2 every year for 24 years. Ah, cool. It's definitely a good thing to get scanned. Okay, what we're going to do here is we're going to take this Pabst fan, which is insane. It has a metal frame, so it's a super heavy duty fan. So you've been scanning them in the background. Yeah, I'm gonna have like I'm not sure how I'm gonna do this yet. I might actually do like a channel point reward where it's like take a break and scan a document and we just go on to the next manual, because I have a lot of them I have to do here, so I don't know quite how I want to handle that yet. So one of these will be negative. I'm going to guess it's the one that's not positive. So if I do this, bingo, I short out the power supply, which is fine. We're at high current. I want to not be. So let's do that. Okay. So I think the fan will jolt a little here. It may not actually run, but I just want to see. Yeah, that's perfect. So I just want to... Oh, that's really nice. That's good. Okay. So we're getting like an actual load. Good. And it's not super loud. So what I want to do is I can confirm that it draws that amount of current. So now I should be able to plug this in and draw that current over here. I may need to increase my I set to do this, so let's try that. So I set is at 7 milliamps. Let's try 0.2 amps. So we do that, and then we are constant voltage over here. I don't know why this isn't drawing more current. It really should be. I increase the voltage. That stays constant voltage. That's weird. Do I want to adjust that? Volt. So this is one thing I find confusing on the manual. Let me go back to that. Let me turn off the output on this, because the manual doesn't really clarify whether or not you need output enabled to sync current. And I'm not sure. No, this manual is not OCR'd. I'm a little disappointed that they don't just like run any uploaded manuals through OCRing. So I'm going to go to here. I'm looking at the manual for this power supply. So operating, normal fast modes, unregulated state. So here is the information that I was initially referencing about current syncing. The operating point is determined from the voltage setting, the current setting, and the load resistance. In quadrant 1, 2 operating points are shown, yada yada. Operating in constant voltage mode. An operation in quadrant 2, which is current sinking, is essentially identical to quadrant 1, and the operating points defined in the same manner. However, the current setting in quadrant 2 cannot be set independently. It tracks a value programmed for quadrant 1. That is, if the iset command 1.0 is sent, the nominal value of the negative current will be slightly more negative than negative 1 amp by the amount shown in table 1.1 and minus current offset. Okay, so that's interesting. So it's not calibrated to negative current. There is an error in that. Okay. All right, well, that's not the problem I'm having. Right now, I just want to make sure, do I need to have output enabled or disabled? Because it doesn't make that very clear. At least for current syncing. So there is enabling, disabling the output here. So output can be turned on and off from the front panel using out on-off key. When the supply is in the off state, the DIS annunciator is turned on and the output is disabled. While disabled, the supply will continue to accept new commands while changing output settings, and when the output is re-enabled. The out on-off key will not affect any other program functions, nor will it reset the overvoltage current setting. Okay. What is the DIS annunciator? Remote programming, I don't think that's helpful here. I need something that talks more about how the current syncing works. So, see, the one I'm on now is for a new power supply and cards for the bill of $560. Whoa. I think on the Novas, mine were a service contract where parts were like automatically baked into that because they never talk about costs and they replace parts willy-nilly. My Dasher D2 terminal, I believe, has had 3 logic board replacements. And I think because they were just on like a service contract where everything was just like rolled in, they just replaced parts at will to solve problems rather than actually try and troubleshooting it. So yeah. Isn't that basically a relay on the output? No, it isn't. And I had this problem with the capacitor reforming. It is shorted across. Well, not shorted. There's a connection, electrical connection between the positive and negative terminals when the output is disabled. So it doesn't just raw disconnect it. Unfortunately, I really wish it had a an actual hard disconnect, because when I was doing capacitor reforming, what I wanted to do was have it hard disconnect and then switch to the 34418 volt multimeter over to volts and then watch the voltage drop on the capacitor as it sat to help determine what the leakage current is. But I couldn't do that because the power supply just discharges the capacitor almost immediately. Although actually, now that I think about it here, I may need to have the output on, because when I would set the voltage and the current to 0, it would still discharge the capacitor. I bet I do need to have the voltage on. Okay. Or the output enabled, I should say. So let's go back to cams here. So out is enabled. We're at constant voltage here. Okay. VSET is 0, or it's nothing. So let's set it to 10. Enter. Okay. We're locked at 10. This is voltage limited. Okay. That's strange. Okay. If I bump the voltage past 10 on this, then we actually start to draw current. We are drawing 200 milliamps of current, which is what I have this set to. If I bump this up, we can go higher. Okay. I set to 200 milliamps, but now we know that the current actually doesn't configure correctly to there. So they said 1 amp would be 1.1 amps in the manual, but I don't think that was right. But I'll do iSet 1.1 and just see what happens. So I'm going to set current to high on the power supply over here. I'm going to crank it, and this thing just went into constant voltage. So I'm going to increase that up to 40 volts. Why not? Okay, that's way, way over My meter gave up. It doesn't know anymore. Ooh, Oh, I think I may have just toasted this. This may not be good past 40. Okay, there we go. Let's not bring this past 40. See, a strange way to do it. My cheapo lab power supply just uses a relay. Yeah. Okay, so this thing doesn't like more. Okay, but we got up to where are we at? Const volt. We are. This is off. Okay, so if I do this, increase the voltage, I'm going to max out at, say, 35. That will keep going. If I drop this to low, I can then control the current, and we can see current over here. As I move, maybe I can make it so that's actually visible to the camera here. There we go. Try and hold that in place. Ooh, that's really nice. Okay, so the current I can now adjust on the power supply, the linear power supply. So that's 1 amp. And over there, it's not 1 amp. Why? Oh, no, that should be 2.5 amps. Okay. Is the reading wrong? I know, honestly, I wouldn't be surprised. Let's involve the multimeter, because I bet the calibration is just bad on the analog meter there. So let's do that. See, this was in 1986 from an authorized service provider in London. Interesting. Okay, so we're going to do, that's positive, so we'll go here to here, and then unfortunately I don't really have a good way of joining those. That kind of sucks. Do this. DC current, just tap those. All right, we're getting 2.1. Okay, so the BK Precision's meter just sucks. That's what's going on here. So, all right. See if I can figure out a way of connecting those. That'll work here. I have a really terrible idea that I think will work well. I'm curious. Not quite. It's a socket that almost worked. Well, what's with the chip smoke? No, everything's fine. The clickety clicks are just... That's just the relays and all the things turning on as I change ranges. That's fine. That's normal. So this is a thing where when I eventually talk about this in a video, I'm going to get so many comments hating on me because a power supply like this one is not capable of syncing current, but a power supply like this one is, but that's only because it's specifically designed to do that. But some people think you can sync current into a power supply like this, but you can't. So it's going to be a very controversial video, and I know that. But this is going to lead into the capacitor reforming stuff so that I can demonstrate all of that. You know, let me see if I can bus the breadboard thing here a little better and then use that. That'll work. So let's grab something here to do that. A big old washer. That's perfect. So I'll just drop that in there, clamp it down. So you meant the display. Oh, yeah. I don't know what the deal was with that. I am not sure this is going to work. Let's find out. Boom. Boom. Not even a little. Okay, let's do wire. Wire will work. I have all sorts of scrap wire down here I can use. Let's just grab some of that. Oh, here's perfect. Everyone loves aluminum wire, right? We can use that. Whoa, humid being, thank you for the 5 gifted subs. We are getting really close to that 2 camera now. That's incredible, thank you. Come on, get in there. BCF84, thank you for the Prime sub. 260, man, wow, holy moly. Okay. Boom. Boom. Now we got it. All right. Really though, thank you all so much for the subs, Human Being and BCF. I really do appreciate it a lot. Let's see, that was the 200 ohm resistor. I should probably put that back in the 200 ohm drawer so I don't forget what it is. Oh, because doing that means that I don't have to remember how to read the resistor codes. See, are you actively reforming capacitors at the moment, or does that need to be fleshed out more? I'm not doing it right now because I'm using all this hardware to do this stuff. But this is working towards that goal. What my objective is here is I'm practicing load testing with the HP power supply right here so that I can reassemble the power supply for the 8-inch floppy drives, and then we can actually load test those before we power. I can load test the power supply for the floppy drives before we power it up, which will make it mostly risk-free to try powering up the floppy drives completely because we will have tested everything we can before then. So that's why to do this, because if the capacitors are going to go bad or they have qualities that are not ideal, if we load test the power supply and then measure it, and I have an oscilloscope here we're going to drag out in a little bit and do like ripple checks on some stuff, because one of the other things about today that I'm planning, I don't know where I put them, oh right here, duh, is I actually have a bunch of power supplies here that are all 12 volt power supplies. I have 2 linear power supplies, which should work perfect until they start to drop out. And then I have 2 switch mode power supplies, which I'm expecting the ripple current to get higher on as we draw more current from them. But the goal is to get practice characterizing power supplies today. So when I do the actual load test on the floppy drive power supplies, I can feel confident that what I've done with the reforming has worked in that the power supply is ready to be put back into service. So this is working towards that goal of getting capacitors reformed, and then this will become the final step after all the capacitors are reformed. We'll put the power supply on a load test and see how each voltage rail works. So that is the current goal and path forward. So yeah, I'm trying to be scientific about this and have predictable and reasonable steps that I can use to do everything in a way where there is logic behind it and not just let's hope it works after I do this thing. I want to know that stuff is going to work and to have confidence in that. What if your load testing setup overloads PSU chip smoke? So, as a benefit of this exact setup, let's go back to this. So let's say we can now see everything here. I can't really see it when I'm leaning down, but I'll just move this meter over here. This is voltage, so this isn't current, unfortunately, but that's voltage is more useful most of the time. So what's going on is oh my gosh, stand upright. Let me walk you through some of how this power supply works and how the other power supply works. So on this one, there are LEDs down here and up here. And you are either voltage limited or current limited on a power supply. So if I decrease the current here, no, increase the current, and then increase or decrease the voltage, there we go. We've switched over to being voltage limited. So the green light actually turned on there. Hello, Gadget Blues. Yeah, you did actually manage to catch one, and especially hello since it's first time chatting. So this power supply, you're either voltage limited or current limited. So what's happening now is we're starving the output because there isn't enough voltage to keep the current going. So if I increase the voltage, then we'll switch over to being current limited, and the power supply is limiting the output by the amount of current. So I can change the voltage higher all I want. It doesn't matter. It can't push the voltage any higher with that amount of current. So if I set the voltage here to like 20 or whatever, all right, then I bring this to there, we can now change the current based on where this needle is at. All right, so the needle moves up and down based on that knob. I'm going to set the needle to about 1 amp, and actually I will calibrate it to 1 amp based on the multimeter there. So we're going to output 1 amp. So this is now capable of outputting 1 amp at about 20 volts. This is drawing 10 volts at 1 amp because the voltage limit is actually kicking in here, preventing it from going higher. But if this was a, let's say 500 milliamp power supply, I can go to I set, and then I can come over here to 0. Let's say 45, enter, and now it's only drawing half an amp instead of 1 amp. So I can limit the amount of current that this power supply can draw so that it will not ever overdraw a power supply. So like when we go ahead and test some of the power supplies here, these linear ones are really tiny, and I intentionally picked those. This one is only 200 milliamps, and we're going to try getting up to the limit there for the current draw on it. So I want to try and get practice. Like if I blow up that power supply, I won't care, but I need to know, you know, like if I go over it, what'll happen, probably not good. But I want to figure out how that all works out. So yes, so I can limit the amount of current. It should never overdraw. The problem though is that I don't know what the power supplies are able to output. So if we go back to, for example, this monster. This is the Micronova power supply. All right. It doesn't exactly have a label on it that tells me what the maximum current is. So what I have to do is I have to look at the parts. Like if I come into here and I look at this thing and I go, oh, that's a Motorola 2N4399, dated 1979 actually, so that's kind of cool. So 70s Micronova. Then I will have to try and figure out how much current can that thing output, where's it connected, what's it doing, and try and deduce it from there. Or I can potentially look at the devices that are in it and try and come up with a rough number to figure it out. Or at the very least, the other thing I can do is I can load test this by starting low and then going high and seeing where the power supply starts to become unstable or overheat or something like that. And then when I first fire it up, I can watch how much current it draws and then see if it looks like it's more than it can supply in its current state. And then if it's bad, then I can replace capacitors. So, there's a couple of things that we can do with all this information. There's a lot that's going into this and trying to be precise and all that stuff. So yeah, let's see. Oh, that sucks, Lady Ironborn. Hopefully that it doesn't go too badly for you. So, okay. I'm starting to feel confident in how power supply current syncing is going on here. I'm starting to really like this setup. So output off disables it, and then output on starts drawing current again. Although we can see even on here it draws 100 milliamps when it's off, so that's interesting. That goes with the it still has an electrical connection even though it should be off, but it definitely does. So okay, that is really weird. How does it know whether or not to source or sync current? Or is it just inherent? I've never really looked into this. It's weird. See, is that an old PS keyboard that you're using for OBS hotkeys? It is, Messreal. This is a Cherry G84 keyboard. Nope, G86. G84 is an ML. But yes, this is, and I've ordered replacements for this, 2 of them that are full length with a numpad and then a trackpad right there, so that I can do the whole thing and not need my mouse and have even more hotkeys. I'm actually really looking forward to getting that. See, pardon me if you've covered this, but have you had success in testing in-circuit capacitors? So Gadget Blue, that's a really interesting question, to ask. So when it comes to that, I actually have a meter here that's specifically designed for testing capacitors. And with it came these. These are tweezers, whoops, for doing in-circuit testing on stuff. You're supposed to be able to probe this onto the legs when it is soldered in place. I never use these because, in my opinion, you cannot possibly ever know exactly what the circuit is around a capacitor to test it in circuit. Because, like, say you have a decoupling cap. It's right next to a chip, and it's probably right next to other chips that also have decoupling caps. So you're going to have parasitic capacitance leaking out to the other capacitors that are nearby, throwing off your reading. I would never do that. I would always lift one leg at least or something, and if it's SMD, that's going to be even harder. But I never do in-circuit capacitance testing. I don't trust it. So yeah, I think it will more likely read better than it should. So say you're trying to do an ESR measurement in circuit, and you have parallel capacitors, the resistance is going to be lower and it's going to look better than it is. Capacitance would measure higher than it should be, which again is going to look better than it should. So generally I just avoid that as much as possible. I will always try and remove them from circuit to do that kind of stuff. So yeah, it's an interesting question because a lot of people will think you can, especially when it comes with hardware that does it, but just on paper it doesn't make sense, at least to me. So let's hear. That's so awesome. I'm tempted to set up myself. Who needs a Stream Deck? Exactly. Okay, I'm gonna let out the secret here. There's a Goodwill in somewhere back east. They got a bunch of the full-size Cherry keyboards in, and they're selling them for $15 each. They normally sell for like $150, so that's why I bought 2 of them. So if you wanted a keyboard like this, now is the time. Go on Goodwill, look for a point-of-sale keyboard, and like cap it at $30 or something like that. You'll probably find it. Super great deal. The switches are rubber dome, so even though it's a Cherry, they're not like MX and nice, but it's not bad. So yeah, if you wanted to do that, definitely now's the time. Let's see. I have this PSU for my Intel 403E white box 486 EISA tower, which is super difficult to recap because the solder mask is 3 millimeters thick in places. Oh my gosh. Wow. Oh, Ness, that's actually not Goodwill's bidding site. That's on eBay. Oddly enough. Some of them use shopgoodwill.com. Some of them just use eBay. That's one of the things about Goodwill is that there are different regional branches of Goodwill. So like mine is Southern Arizona for the location I'm in, which indicates to me there's a Northern Arizona location. And then I know there's like East Coast Goodwills, and then there's West Coast Goodwills. And I'm pretty sure it's mostly West Coast Goodwills that use shopgoodwill.com. I'm not even sure that my Goodwills can put stuff on shopgoodwill.com. So it's kind of weird. Yeah. So let's see. I think the answer is if the output is higher than the set point, it tries to source sync, or if it's lower, the other way around, but I'm not an expert on that. Yeah, it's kind of weird. I don't get it. Yeah, because I really don't understand how it switches between the two. I would like to know more about that. Let's see, I posted a comment a bit ago saying one of the current capabilities for the Nova 2 PSU. Ooh, okay. Maybe it is documented then? Because I'm not sure. I would hope, because if it is documented, that's going to make my life so much easier. So it doesn't switch actually. Yeah, that was my thought. Is that there's just something linear magic MOSFET-ness about it. But yeah. See, for retro keyboards, I use the Fujitsu thing. It has Fujitsu Peerless switches, combo mechanical rubber dome switch. Interesting. Feels like Model M, but lower effort. Okay. and it's got a Win key. That's definitely nice. I'm at the point now where I've just in Linux rebound caps lock to the Windows meta key so that I don't have to deal with that anymore. And that's just become my go-to because I use Model M's a lot. This isn't because I'm trying to go for a vintage keyboard with this thing in particular. It's actually just because the Cherry point of sale software makes it so easy to rebind keys. These are all just shortcuts or macros up there. And that works perfectly with OBS. So that's why I'm using that. For vintage keyboards, I really just use Model M. I mean, there's a lot of good vintage keyboards, but I like the Model M, so I just use that. Let's see, I found it handwritten on the power supply. Oh. Okay then. That's a thing. No, I don't think there's anything like that on mine, unfortunately. That would be nice. But I'll be looking through the documentation that is available publicly. There's not a lot, but I'll see what I can find. So, let's see. Info held, I think. Hello, since it's your first time chatting. And yes, Hellcroft was beyond absolutely amazing earlier in the stream. Oh, yeah. See, selling your Commodore 128 tomorrow. Caps lock is a physical lock toggle. The button stays down. Yeah, those are really cool. I can't remember. Is this like that? Oh, no, that just doesn't have it. But I have some keyboard that's like that. Oh, it's the HP Series 80 stuff. Those are a physical lock, but they have the awful Stackpole / high-tech switches. So they lose any credit for that by having the most self-destructing switches that have ever existed. Well, I don't know. It's a tie between those and foam and foil. So far, I think I'm the only person who has a solution for repairing Stackpole switches. But at least for foam and foil, you can just refoam them. See, your guess your lucky your HP85 keys all still work? Yeah, it's because the square tubes, they crack at the sides and then the key stem slips farther down in and splays it out and then it wedges inside of the keyboard frame. So that's the problem. So I actually have, I don't know if I have it over there. I've reprinted all of the key stems in my HP86 with 3D printed ones, but I use an FDM printer, so the external texture is really rough. I had someone send me some SLA printed ones, which are super smooth. Oh my gosh, they're perfect. They're incredible. So if you're ever getting, you ever have a problem with a Stackpole high-tech keyboard like a TI-99, the HP Series 80, Model 1 TRS-80, get the stems that I have on my GitHub profile SLA printed, and oh man, they're amazing. So yeah. Let's see, I have an Apple Extended clone, and the locking cap switch is broken. Ah, that sucks. You bought one of the cherries from Goodwill? Cool. I'm glad that I was able to relay that to you. See, hello, Welsh Boy 2008. So we should probably get back to this, like doing actual work here. I didn't. At the last stream, I ended it kind of like ambiguously on what we were going to do today because I have a bunch of projects that I'm working on. Like I want to get back to the CryoFlex stuff on the 8-inch floppy drive, and I want to reform caps, and I want to work on scanning the documentation, and I have all these projects going, and I don't want to I don't want to start something else and then like lose track of what I'm working on and then come back later and be like, oh no, I did stop and I didn't finish that. So I'm trying not to start anything new. So this stream was kind of like, I needed to do this load testing, but it's kind of like a really simple thing to do a stream on. I just kind of wanted to do it. Yeah, so many projects and so little time. Exactly. But then there's the ADHD thing where I will absolutely forget I was working on something and then not get back to it. And I don't want to do that with this stuff, especially when I have it partially disassembled. So I'm trying to not forget and mess things up. See, now you're the owner of a new unboxed point of sale keyboard from Cherry. There are worse things about it? Yeah, no, those seem pretty good. I'm happier with it, so. It's way cheaper than the Stream Deck. Yes, those ones are. I was gonna pay $150 probably for that exact same keyboard. And it was actually kind of hard to find them in English, because I think they're desirable. So yeah. See, I need to fix 3 Diablo removable hard drives from vintage mini computers, but but I've got time since I'm only 19. It's yeah, for me it's I have so many projects going on. I don't want to start more projects and then forget. So that's the thing. I will forget. Like I'm staring right across from here, right behind the camera. There's 3 amazing terminals that I really want to get to that are nice little self-contained projects that I could totally start working on. But I don't want to start tearing into one and then, you know, oh, the scanner's here for the manuals now, let's start working on that. Or, oh, I figured out the cap reforming, let's start working on that. And then there's a terminal torn apart. Bad secret. Dasher T2 terminal was like that and was sitting open, torn apart for over a year. And I actually had to put it back together when I had to move. So I know this will happen. I'm really bad about it if I hit a wall or something. So yeah. That's why I decided to sell everything that I will never find the time to work on. I kind of don't blame you. I just tend to keep everything because it's too much fun. That and I'm doing this, so it kind of makes sense. See, that's my problem entirely. Unfinished projects, yeah. You only ever need 1 terminal? Well, I mean, yeah, the Dasher's pretty awesome. I mean, Dasher is ultimate terminal. I'm never going to get anything that's cooler than that. So there is that. But those televideos, it's really cool to have 2 televideos because now whenever I set something up, I can have like an actual like multi-user system that is, it'll feel authentic because it'll be set up in that kind of way. Oh, I just realized I've been running power through this thing. How's it heat-wise? Oh, it's fine. Yeah, that's nothing. Because I've replaced the power supply in that from the Pabst fan that was in there that's probably super high flow. Oh, it's only 2.5 watts. How much power is the Noctua? Noctua is 1 watt. Okay, well, it's probably higher efficiency as far as how much air it moves. But it's definitely going to be less cooling. So, yeah, probably okay. See, I'm looking at building a replica Cray 1 using Pi Zeros. That'll be interesting. I wouldn't mind like a little mini desk size one. That would be cool. Would you use like SimH or something for running that? Let's see. So many things I wanted to learn about electronics, sides of stuff that I start projects and never really get them done because I hit a wall. Yeah, that's exactly what happened with the Dasher. Is that I was working on actually learning capacitor reforming using this as my output power supply, which sucked because I had to manually modify the current and voltage and all that stuff. And then I hit a cap that is a hybrid multi-element capacitor that has multiple capacitors in it, and it was like, obviously I can't just easily reform this, and I need to know how are the layers intertwined in that. Like if I start reforming one, do I need to reform another one at the same time? And then I heard that generally they're garbage and that you should just gut it and replace it with modern capacitors. Like you cut the bottom off and take the cap off, or the can off, and then stick some modern caps in there. So I meant to do that, and then I never got around to making a DigiKey order or something to get the caps, and I kind of forgot. I think they're actually still written up there. Yeah, they are. So that's the other thing. It's 100 volt and 125 volts on that cap, so it's kind of weird and hard to reform. So yeah, it's a whole thing. Let's see. Oh man, way too many in progress projects to talk into a podcast. Yeah, multi-user Nova 4. I mean, I assume it's possible because it's one person using that whole monster would be hilarious. So it's got to be doable. Let's see, Dr. Awesome Pants. Hello, since it's your first time chatting. We have left supplies and meters on for like 1 week at work and they're fine. You're not sourcing too much current anyway. Yo, yeah, well, the thing is that it's only, I was curious how hot it was getting. This thing's rated for 2 amps and I'm currently running it. It's rated for 100 watts. And I'm currently rating it at like probably 12.5 watts there. So 1/8 of its output. And I was just curious how much heat it was going to be doing or pulling. So if I actually set it to 1 amp here, I'm going to let it set for a little bit. And I'm going to bump the voltage up. Oh, I'll bump the current. Actually, I'm going to have to go to high current. There we go, 1 amp. And we'll stop around 25 volts here. And I'll let that run. So that'll be 25 watts. That's about a quarter, I guess. You know what? Let's just disconnect the meter. Go to 50 volts. There we go. So we'll run it at 50 watts, see how it does heat-wise, because I'm curious here. I don't know what it's going to do. Because, yeah, I replaced the fan in the HP power supply, so I don't know if its cooling capability is up to snuff anymore. So this is actually a good way to do that. Let's see. I need to get a replacement case for Amiga 1200. Ooh. I think, yeah, you're lucky with the Amiga stuff. They're actually making that stuff for some reason. See, most of my projects end up not really finished, but meh, it works. That's the best way to do it, because, you know, who cares if it's perfect? If you get it working, that's all that really matters. So yeah, I have to stop bringing home stray cats, so to speak. Now own quad Pentium Pro server. Oh man, that's amazing. Just to save it from the gold reclaimers, that's super cool. Out of curiosity, does that happen to be a compact? Because I keep meaning, I'm hoping one of those shows up local, like a compact Reliant Pentium Pro or something server. I bet it's not rack mount, because I want like an early rack mount server. Oh man, I am way behind on chat. You guys are, we're having some fun right now. Would it be possible to set up so you can interface the terminals and use them to do terminal stuff on streaming machine on stream? So one of the problems is that they use pre-VT100 protocols. It's technically possible to use them. It's just not ideal. So anything that like moves the cursor around on the screen, Vim, less, anything like that, doesn't work at all. It just completely messes it up. And you lose orientation, and it'll send like weird escape codes that'll do like reverse and underline and all that stuff. So you end up with a kind of a garbage output. It can really be a mess. So it's functional, but you have to really lock down Linux, the serial console stuff to the point where it becomes difficult to use, and then they're super slow. So it's possible, but not ideal. Desperately want to learn 6502 assembler. Ooh. I keep struggling to figure out how to start because I want to use real hardware to do it. Yeah, I don't know. You probably want like something like an AIM 65 trainer. That would be the way to go. I think that's a 6502. But yeah, you basically want a trainer. You program opcodes in through a hex keypad. You know, I bet they're like a KIM1. Look up if there's a KIM1 or an AIM 65 emulator. Play around with that just a little bit to get an idea of whether or not you want to try and go after the real hardware. But those are extremely desirable because they're simple and easy to understand and fun to play with. So yeah, real hardware becomes difficult. Let's see. Okay, it's a compact tower. That makes sense. Yeah, because they took the tower systems that I think were more prominent, or I think it was like only towers in Pentium Pro, and then Pentium 2, they came up with the rack design, where they basically took the form factor from audio equipment and stuff like that and put computers in there. So you have an AIM Rockwell 65 and a KIM1. That's awesome. Let's see, I have a KIM1 replica actually that I haven't built. You should totally use that for doing 6502 assembly learning then. Yeah. Good luck with getting a VT100. I got mine and some others from the Department of the local bank 1 year ago. Yeah. I definitely want a VT100. I really badly want a VT100. Just like plain straight up VT100, because that's such a... I want that more than I want something like a Lear 80M3. I want a VT100. I want a cool terminal that's old. Unfortunately, I think they have foam and foil keyboards, so I'll have to fix that. But then it'll be a nice, usable old terminal with modern systems, and it'll be amazing. See, check out my friend Dave Plummer's recent video on the KIM1. Okay, cool. Yeah, that would definitely be a good, yeah, Tater's Games, I would recommend that, actually, as if it's a good video on the KIM1 for getting you into it, because it's really nice, so... Learn 6502 on the VIC-20 and C64. That's another nice way to go. I can't remember if they have a built-in monitor or if you need some like card to do that more easily. Like the, I think it was the Action Replay can do that. but that would be a way. It's just not as easy because then you have to deal with all of the clunkiness of the computer itself. That's why the Kim 1 and the AIM-65 are so nice. Although the AIM-65, think about it, that's a fourth device, isn't it? That's not 6502 assembly. So Kim 1. The benefit of the Kim 1 is that it's it. That's all it does. It's just only hardware. It's like programming on a calculator, but in hex. So, yeah. Let's see, you need an ADM3A because my Star Trek game for the Nova 3 uses ADM3A escape cursor addressing. Well, I have the TRS-80 DT1 terminal and the now the Visual 200 over there that both emulate ADM3A. So I could use those to make it at least functional, but I would want an ADM3A too if I could get my hands on one. That's just extremely desirable for all the reasons. Whether or not it's just you like old terminals or you like the Kraftwerk album, there's tons of reasons. Those are expensive. See, is there a macro? Oh, hold on. Okay, is there a macro assembler for Kim 1 though? One where I can code using mnemonics rather than raw hex. Oh, no, there isn't. Tater's game. The whole point is that, well, the idea with the Kim 1 is that you become familiar with how the opcodes work. So you start this opcode and then you load this register and then you do that. It's meant for really beginning your journey on assembly. So that's why that. So, see, 128 has built-in monitor and so does the Apple II. So those might be good systems. I don't know. Because I was trying to kind of go away from anything that would also have BASIC and would have tape loading and disk drive stuff, just trying to keep it super simple, make it really easy to use, and not try and save software. I think trying to save your software at the beginning level will make it difficult. So, let's see. All right, Lady Ironborn, thank you for the gifted sub. Kim 1 is a machine language trainer. Yeah, it's exactly what it is. It's not an assembler. Well, you wanted to learn 65. I mean, I guess if you want to learn 6502 assembly, then you probably want an assembler, I suppose. I was just thinking, learn the raw opcode so you get the idea, the handle on what the assembly does. If I could do that, I should probably find an x86 trainer. That would be cool. I would like to start with one of those rather than an assembler monitor type thing. Let's see, it's Data General Basic written, originally Nova 1200. Multiplayer requires an HDD. Ooh. All right, feeling the heat. It's actually about the same as before. Okay, so I think maybe it's gonna work out well. If that doesn't really have a significant change after that time, at half load, I think it'll be good. All right, should we take it to the next step on this? I think we should. Was it UJout or was it JMetal? Someone was telling me that the CompuPro hard drives I have are extremely rare. I figured I'd just mention on eBay right now, there are 2 hard drives for S100 systems that just showed up. Now I'm starting to track that stuff on eBay, which is going to really hurt one day in the wallet department. But yeah, figured I'd just mention that there is some of that. See, need some ODBFS sensors to log temperature. That wouldn't be the worst idea. I have thermocouples for my Fluke, but I'd have to open the HP up again. And I've done that so many times now. I just want to be done. I think it'll be fine. I could log the output, but I think it's okay. I don't think I'm going to get anywhere near to loading it. Like, it's not... Floppy power supply is not going to be 100 watts. The Micronova power supply, I don't think any one rail will be 100 watts, so it should be fine. So I think I'll be okay. Okay. Yeah, I think we're good. Let's do some new stuff here. So I'm going to grab, why is this here? I think I just brought this in case I wanted to use a Wacom at the office. Okay. I'm going to grab my oscilloscope, and I want to see what the voltage ripple is like. Is this plugged in? I hope it's not. No. I want to see what the ripple is like when we connect a normal power supply to this thing. So let me get this set up. Unfortunately, this is an analog scope, which is gonna look terrible on the cameras, and there's absolutely nothing I can do about that because it's just gonna scan at whatever the rate is that the time base is set to, so it's not something I can fix with shutter. My power strip all full again. Is there something I'm not using? Let's see, the VGA capture system. That stuff's not on right now. Pop that in there. Okay. I'm gonna need some probes. Where are those at? Right there. Woo. See, need slow phosphor CRT? That would be super cool. I would love that. For video purposes, that would be amazing. For everything else, that would kind of suck, but I would be very happy with that for video. So, let me grab one of these. Can't remember, these 50 volt? They're probably good for whatever I run through this. They're not rated. Oh well. Okay. See, I used file share, lock share, player position between users. Okay, interesting. Alrighty. Trying to think about how I want to do this, because I want to do the don't blow up your oscilloscope thing, because I'm going to be measuring power supplies. I think I'm going to be good, because none of these are grounded. So, we'll go with that. I'm going to start with a high amperage 1 amp switch mode power supply first here. So I'm going to turn off this, and I will be connecting that. The power supply here, the positive side, is connected to the thing there. So we have, I smell some hot stuff. Is it this? Yeah, it's that. Okay, that thing's way hotter than this is. So, yeah, I was just generating heat here, so makes sense. All right, so I want to connect these two things. Is that like super low? Is that because it's on cow? That doesn't seem right. Yeah, something seems a little weird there. What's going on? It's at 10x. Let's maybe get rid of that. No. Can we play Space War in your oscilloscope? No, not quite. It definitely got too much 1970s computers from 19-year-old, but it all has either been given or saved, so I can't complain. Yeah, that's the way to go. I'm trying to save basically as much stuff as I can. That's how I roll. See, this is DC. We're at like super duper crazy low voltage. The calibration signal should be more than that. Something weird going on here. Wriggle mode, yeah. That is really offset for AC, and I don't like that wobbling. Yeah, why is that waving? You guys can't see it. Vertical gain is off. Cobe compensation off a bit. Yeah, I'm really not sure what's going on here. Something feels a little weird. me try channel 2. See if that's as wonky. So vert mode, channel 2, position, all right, voltage, coupling source, channel 2. Let's go with ground. Okay, channel 1, ground. Okay, a little weird. There's XY. So there, boom. And why does that not work? Oh, because they're set to ground, right? No, ground, ground. Okay, so channel 2 controls vertical. Set it to, ooh, that's gross. Okay, but that's because XY, so let's turn that off. Okay, there we go. Now we got channel 2, but that's still really weird looking. That's not what that should be like. Volt div is way too sensitive on both channels. Yeah. Well, that's the thing, is that, like, I should be able to go, oh my gosh, I'm an idiot. Am I seeing the ringing? That's what I'm seeing. Oh. Okay, let's go. Half a volt, DC. Yep, I'm an idiot. Never mind. It's fine. Okay, let's continue. Hello, Just. Not a whole lot. Man, it's mostly just blabbering and messing it up. Okay, so what I want to do next is I need to figure out how to connect a barrel jack, 5.5 millimeter, to banana jacks, which is not going to be easy. One thing I can do is, since I'm coming off of the HP thing over here with this one, is I can just take that out and then I can replace it with a clip. So I can grab this. All right, that eliminates that. All right, so I can clip on to whatever the center post one is. This is unlabeled, so that's cool. Then I can just tap the other side. So I'm gonna do VSet 10, but that doesn't actually change anything. iSet, I'm going to do 0.25. Pop that in, and then I will just tap the other side of the thing, this, to, did that unplug? I don't think that should be out. Hold on. That goes in there. Hold on, what's the current loop? This to here, to join, to, yes, okay, so negative, positive, all right. Oscilloscope shaking, yeah. Thank you, Taters Game, for the 100 bits. It was very silly of me. So, okay, I should be able to just tap that, and then whatever. Actually, you know what? I'll do a voltage measurement first with the HP to figure out which is which. Or HP. The 34401A. Figure out which tab is which so I can connect this correctly the first time. Okay, beep. Good. I like beep. Beep means the probes are still good. Okay, so the outer splayed one positive, other one negative. Okay, so short is positive, long is negative. Okay. So with this setup, The clip is positive, negative's going to, yep, clip is positive, so clip to the short side. Boom. And then we will tap the long side, and we should draw 1/4 of an amp. Boom. I think that's correct. Our output is on. I set 1/4 amp, okay. But then we're not drawing 1/4 of an amp. I think it's because we're locked at 10 volts, so let's do VSET 12. Actually, I bet that's not it. Why am I only drawing 2 millivolts? That's weird. That is negative. This is positive. Something seems a little wrong. Do voltage check again. Positive, negative, 12 volts. Okay, this is a 1 amp power supply. I should be able to source 1/4 of an amp. Let me just make sure. I think it's disabled, and then this is not. I'm confused. I'm just going to turn it off and on again. Off, on, VSET 12, I set 0.25, okay, and attempt to draw, and it doesn't. Okay. Why? Maybe you need to lower the voltage limit and it's running in constant voltage. Perhaps VSET 5. Quarter amp. Okay. So that is it. Alrighty. You're getting 1/4 amp up there, but only 67 milliamps at the 34401A there? That doesn't make sense. Huh. Well, let's try tracking ripple as well. So there's that. This is way bigger. What? Oh, that's ugly. What on earth? That is 5 volts per division? What? That doesn't make sense. And it's reading 5 volts on the fluke. Okay, I'm going to try off. 12 volts. Okay. Something feels like it's going weird. This is not grounded over here, so maybe I should do that. Oh, I think, yeah, it needs to be grounded. Okay. Speaking of HDDs, Blue SCSI's SCSI emulator for that's not unusual. What's unusual is that someone has made a device that hooks into Blue SCSI and creates audible hard drive seek sounds at its next level. I saw something about that. I actually put together a Blue SCSI on stream here once. So I maybe should check that out. That would be really cool. Okay, now this is all good. I don't know. I don't like how this drops it down to 12 volts. VSET 10. enter. Okay. Let's do AC. Okay, so this is 10 millivolts per division. No. That's 50 millivolts per division now, so that's a lot of ripple. If I turn that off, that's 1 volt per division. That's a whole lot of ripple. So that's a whole volt of ripple. Ugh. All right, and then I will load it. Ooh, it's weird how it changes. That's 10.5 volts. This thing loads this really weird. I don't like this. I'm going to do something a little sketchy. I'm going to set this to 15 volts. On, and now we're at 15 volts. That doesn't make sense. 1 volt. VSet 1. Okay, VSet is now 1 volt. And now we're at 11 volts. Okay. So if I do iSet 0.5, enter. Only doing 100 millivolts. Oh, output disabled. Oh, now I'm a little concerned. Let's try that. 1 volt. Oh, it's really cranky. I'm glad I'm testing this. This is weird. It was so easy with the BK. What gives? Does the switch mode power supply just suck? Is that what's going on? It like gets disrupted by this thing? I can also hear the switch mode power supply, which is a little unnerving. I can only hear it when it's connected to this. See, what happens if I plug it into the, or connect it to the fan? Can you do negative iSet? I don't have a negative button on it, so no, I can't. So if I put it into this, short is positive. So that makes sense, but I hear like a weird sound when it first turns on. I'm not sure if it's a fan or that. Let me move the fan over. The fan blades are very thick and scary when your finger touches them and you're not expecting it. Okay, positive. Okay, it's a fan. Oh my gosh, listen to this fan make a weird whimper sound. I think it's bearings in it that are like bad, because I did replace it because they were super loud. Oh, that's weird. But it works, so let me do this. Let me clip onto it. That thing will draw more current than this power supply can output. So this is a load test for sure. So I'm gonna have the ripple over there. Also, since it's an inductive load, it'll do weird things. So that's 5 volts per division. We're getting like 7 divisions, so that's 30 some odd volts, millivolts ripple. That's pretty expected. That's interesting. The big bursts when it's trying to start, but it can't. See, this is a relay to make sounds. That fan sounds rough. Well, that's why it was replaced, but also there was a wire bumping into it. So if I do that again, it won't sound as bad now I moved that. There we go. But that is 5 millivolts per division ripple, 6 divisions this time, so 30 millivolts ripple, which is okay. But why am I not able to load it on here with this? So, ground, and see, I set 0.25. Actually, that almost seems like it's working. Nope, it's 39 milliamps. What gives? Oh, the output's disabled for one. There we go, 2 amps. And just weird. There's something I'm missing here. Let me go back to the BK. This is why I wanted to do testing, because now I can make all the stupid mistakes I want here, and it's in an environment where it's understandable, because I really don't know what I'm doing. I'm trying to learn how to do this, so. Okay, so that's positive. This is negative. Boom, boom. Turn this on. That's not plugged in. Let's plug it in and then turn it on. So you mean fans aren't known for being steady loads themselves either? Well, I was just mostly making sure that the power supply was working, and I was trying to see how it squeaked when I plugged in the DC. Yeah, the fan is not a good load test. It is absolutely not. I was just using it to make sure that the power supply was working still. I hadn't like just killed it. So, okay. 20 volts. All right. And immediately we're doing 400 milliamps. What? Oh, bump the voltage. It works. So let's mimic this thing. So this is 12 volts at 1 amp. So we're at high. I'm going to set that for half an amp there. Okay. And that's just like working. Does it not work because it's switch mode? Here we're at, well, that's at 13 amps or volts, but see. Okay, so 12 volts, like locked-ish. All right. I'm going to set it to, I set, that's 300 milliamps. Okay. So clear entry. We're not drawing that. So VSET is set to 1 volt. So let's say 50 volts on VSET. What will that do? Enter. Didn't change anything. Oh, we're output disabled. There we go. Oh, the power supply did not like that. The other one. So that's a thing. Okay. VSET 1. Enter. Out. Okay. Now we're locked doing basically exactly what we should. And my little LED meter is like roasted again. Oh, I think it might be done. I think it really didn't like that. It might finally be Gonski. Let's see. Out, off. Oh, yeah. I think this time it's actually gone. This time it seems like it's actually toast. I don't see anything that's blown on it. It does not seem happy. Yeah, I don't think it wants to come back. Well, that's disappointing. That was basically inevitable. It's all right. All right, output disabled, output enable. Okay, this is set 1 volt. All right. So there's that. And if I put the fluke on this, all right, seems like the voltage limit was something below 50. Yes, yeah. I don't actually know what it was. So that was not the most fair. But let's say we put the fluke on here. All right. Well, the probes are going to stop working just to mess with me. Yep. Where's it bad? Come on. There we are. Okay, so. Positive and negative. All right, so we're at 11.4 volts. To your LED voltmeter you served as well. It's nice while you last, but now you've blown. Yep. Oh well. I'm gonna keep trying it a couple of times in case it comes back, but I'm not too optimistic. Nope. Poor guy didn't have a chance. See, if I take out the stuff, you can see what's going on there on the back, but I don't see anything that's like done blowed up. So I don't know. See, is there a fuse anywhere on there? It doesn't look like it. So I don't know if there's anything that's going to take a moment to reset. Bet the LED elements are all fine though, so I might end up reusing that. Do you own a microscope? Yes and no. I don't own a true analog microscope, and I don't have like a video microscope, but what I do have is a video magnifier, which is meant for people with reading trouble. So there's that. And then I have macro lenses that are absolutely bananas. So yeah. But anyway, VSET, whatever here, doesn't really seem to make a difference. If I set it to 5 volts, voltage didn't change over there, so that's good. VSET 13 volts, that changed it. So now this is higher, okay. So what if I do VSET 0? Boom. Maybe that's what I need to do for the other one. So we're currently set to 0.3 milliamps, but we're drawing 400. So let's do 0.25 amps. We dropped. Okay, so that's a thing. The SAW 89 is a voltage regulator in the microcontroller. Maybe the ADC input blown because, oh yeah, that is possible. Yeah, that the microcontroller ADC's toast. That would make total sense. Yeah, well, I'm going to keep letting it just chill in case it comes back. I don't know. All right, so maybe procedure for syncing current will be 0 volt output, so V set 0, and then I set to the limit, times like what, 2? I don't know. If I set it to 1 amp, so I set 1, it should, yeah, voltage dropped because it's basically short on the power supply. The power supply can't output that much. So if I increase the output past 1 amp on the power supply, now it's good. Voltage has dropped slightly. I could compensate for that a little bit there. So now we're drawing 1.1. Let me see if I can find that chart it was talking about, because there's something about like when you set it to have a current limit, it's got a thing that's like bad about it. Let's see. Load considerations, output isolation, no. Okay, table 1.1 under minus current offset. Okay, where is that? 1.1. Okay. Output impedance, minus current offset. Where is it? Oh, table 1.1 continued. Okay, table 1.1 is big. Okay. Programming accuracy, input current, DC output, programming resolution. A negative current limit tracks with positive current with a fixed nominal offset. See, hold on a moment. We need TTS for points. So, Hellencroft, I've actually been thinking about this. Ooh, hello. Oh, we have a byte break. Okay. I want to buy a deck talk. And I want to use that for TTS, because I think that would be amazing. But it's got to be a real deck talk, not just an emulator, because an emulator is not, you know, anyway, that's fine. But I want a real deck talk to have like an actual TTS thing over here to talk to me. So at some point we'll do that. But Lazy Crypt, June 86, page 200. All right. Let me grab that. Although let me first see this, then we'll do that. Okay. So go to laptop capture, or at least a sound alert. Yeah, that could be done. Something get my attention. Yes. So okay, this is the manual here. All right. So a couple pages in section 4. All right. Here it says that the PDF is going to have to reload. Okay. That is, if the iSet 1.0 is sent, the nominal value of the negative current will be slightly more negative than 1 negative amp by the amount shown in table 1.1. And it was saying somewhere here that it would be minus 1.1 amps. I don't remember where it was, but here it says by the amount shown in table 1-1 under minus current offset. Okay. So let's go to table 1-1. This is section 4. So we go forward to minus 1.1, and then it says the negative current limit tracks the positive program value with a fixed nominal offset. See section 4. And this is table 1.1. What? So, oh, okay. The negative current tracks the program value with the nominal offset shown as below. Minus offset. Okay, 100 milliamps. Oh, so is it always plus 100 milliamps? That would explain it. Okay, so if we do 1. Oh, all right. So if I want to do 250 milliamps, then I will do. Oh, check out the Wikipedia article for Deck Talk. All right, Deck Talk. 250 milliamps. 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 2 This is a trend, all right? Check this out. Tandy 1000. Wait, did somebody change it? No. No. View history. Somebody changed the picture, because this used to be the picture for the Tandy 1000. No fair. What gives, man? That was an iconic picture. Lame. Who's the spoil sport? When did it change? Oh, it's there. All right. July. There. Move photo up a little for better layout. That. And then, where is it? New photo will move. Baba 73. Boo. That's all I have to say. Lame. Is there a talk page for this change? There's a talk page for the person. I want to revert back to the cat picture. But that's excellent. We must protect this page. Deck Talk Cat must be kept. Anyway, but yes, I would like a dedicated Deck Talk hardware. Something like that would probably work well. I bet that's serial. Someone else mentioned a Speak and Spell. Oh yeah, Hellencroft, Speak and Spell. TRS-80 voice synthesizer, that would probably work. Oh wait, TRS-80, I thought you said TI-99. TI-99 voice synth might work. Using the TMS, whatever TI thing made. That's the same thing as the Speak and Spell. The Speak and Spell can't be used. The Speak and Spell stores phonemes to build small words, and it cannot do arbitrary speech synthesis. So when you actually got a new cartridge for the Speak and Spell, it would add more phonemes specific to the application that was going to run there. So you can't just go with a Speak and Spell. The TI speech synthesizer, I think, could be used, but it's a lot more complicated because you have to build phoneme data structures because it's based off of the same chip. It just has a larger data bank in there. So you couldn't just send it like arbitrary text, I think. It's been a while since I messed with it. I don't have a TRS-80 speech synthesizer like Gadget Blues mentioned. That would be pretty sweet. I am on the lookout for a Votrax speech synthesizer. I came this close to winning an eBay auction for one, and I got outbid. I was really disappointed about that. So eventually I'll have a Votrax, because I'm trying to get that. That's one that's compatible with stuff with like the PET or the Apple II, so it's a really early one, just general purpose. But I want a Deck Talk in particular for this use case. So get Imzai speaking lurk. Would you like to play a game? Yeah. Everybody really wants to associate the Imzai with war games, but I just like it on its own. See, the user is dog, little dog, cat. See, streaming overclocking YouTuber always has his cat walking around on his desk in videos. Suspected the catless picture for the Tandy is sharper. Maybe. We got to AI upscale the cat picture to make it qualify. You can still buy a real Deck Talk chip. Seriously? Whoa, that's cool. See, what about the early Sound Blaster text-to-speech? I'm not familiar with that. Interesting. But okay, I should go grab July 1986 byte, and we're going to look at page 200 and see what's going on there. So let me do this and also this button. You know what I should really do? So like the way I have this keyboard set up here is that there's a hotkey here that'll switch between capture and cams, all right? So those two cycle there, but you'll see down here the laptop's still there because I have laptop enable as a separate button and VGA enable as a separate button. I should really have these. So the way these work actually is when I switch like I'll use these as an example. When I switch between the different camera sources, it actually, each key presses all the other keys kind of as well to hide the source. So what I should probably do is have these keys also press this key to go back to the camera view as opposed to the capture view, because I keep pressing these and it doesn't change the capture view. So I should probably do that. I'm kind of just saying it out loud to make a mental memory that I need to do that. So, all right, June 86, page 200. You could even make it sing with some weird commands. With the deck talk or the, man, I have so much more information along those lines that you realize. The deck talk, yes, the deck talk can sing. I know that, absolutely, for sure. So, June 86, I'll be right back. Okay, gotta be this one. No bonus issues. Ooh. Oh. Okay. I think I know what we're about to look at. Deck Talk is better. Deck Talk is really, really good. Okay. So, this is going to be slightly complicated here. Give me a moment, because I got so much extra cabling on this. If you want a movie recommendation this season, has gorgeous 70s IT computers as an extra. Track down Colossus, the Forbin project. I'm not familiar with that one. And I've seen a lot of weird 70s computer movies. Does it have the famous Burroughs panel in it? Because that one's like always in there. So you borrowed Drago one to do some testing with? Yeah, his is actually like a whole computer that's built specifically for that, so I'd have to take his whole computer, and it's just like main 46 if I remember right, so probably not. It's an AI Singularity movie. Ah, okay. Okay, I think that'll hold, then I'll tip this back. See, one of my favorite movie channels, Welcome to the Basement, did Colossus Forbin project 3 weeks ago. All right. Okay, let's do this. 5-minute timer.
Okay, 5 minutes. Starting now.
I hate seeing stuff like this. That's like mouse or cockroach poo. There's little brown specks on there. Gross. Anywho, we're going to page 200, which I'm going to guess is a deck talk. Actually, you redeemed that before I mentioned that, didn't you? So this just happened to coincidentally be this. Ooh, hello. MIDI project, a MIDI interface for the PC. Okay. I'm also slightly distracted by this. I almost had a 3M tape just like that to hold up over here. Okay, the MIDI protocol. So, wow. Okay, geez, this ad is really disruptive. So this is the article continued right here in the middle between these. Wipe poo off with wet wipe? Yeah, I don't have those in the office right now. I'd have to use like just a towel that I would dampen. Okay, so this appears to be mostly a written article, not, doesn't have much imagery going on. MIDI programming. Wow, processing the MPU 401 data track stream. Holy moly, this is kind of cool. So this is going through a bunch of stuff. Ooh, hello. So we have some actual code. Looks like C. Although these comments are not standard, but the structure, const, and all that stuff is. Interesting. Why type there? Now that I'm not familiar with. Which issue is this? This is June 86, page 200. But there's a lot going on here. This is going through how to actually process MIDI as a protocol. So MIDI itself, I believe, is carried over serial, and it's UART basically. I don't know what the voltage level is, but you can interface with it with like kind of any hardware. That's why you can use like an Arduino or a Teensy or something like that to do MIDI interfacing. But there is a whole protocol on top of that that carries the data. So this seems to be going over all of that. Really, this is very in-depth. This is a complicated article for a later issue of Byte. This is impressive. It's Pascal. Okay. MIDI is TTL serial at a weird baud rate. Yeah, that's what I was thinking there. So, ooh, yeah, nice color graphics on a AT and an XT. Holy moly, really? What? What are you going to use as your video card on an XT for that? Man. Does it come with one? You know, obviously you can do EGA or stuff like that. But RGB, like analog, is not as common. Okay, so that's it. Ooh, there's an Atari 520 ST review in there. And that's, what? Faulty power, give your hard disk, line 2, like voltage sags, brownouts, power conditioner. So there's a power conditioner for an XT? That's hilarious and huge. What is that? Just an isolation transformer and probably some giant capacitors? Weird. Yeah, that looks like ray tracing to me. Let's see. But yeah, this is a more difficult article to go through just in 5 minutes to like check out, but that's really impressive. Oh, I went back a little bit. So they start out by how to actually interface with it, and then they go through how to program with it. So system real-time messages, system common message, they go over system exclusive messages. That is really nice. System exclusive stuff still isn't really that well supported today. So system exclusive messages are like custom hex formatted codes that you can send to a specific device, and they can be used to configure special features on them. So like Roland SC88 Pro will use system exclusive messages to configure the filter effects that are part of what makes it the Pro model. Normally you'd have to key in on a separate little key section on the unit at the bottom, but you can't send like normal like chorus filter or reverb special commands that exist for that. If you want to add like overdrive or something, you have to send a bunch of heavily byte structured formatted commands, and you do that over system exclusive. So that's cool to see that being talked about here. But that is it for the 5-minute section, and this is a very impressive article for this issue of Byte for being so late. So that's cool to see. See, at my job they made I/O controllers to process control connected over MIDI and to an Atari ST. Interesting. See, I have a LAP PC1 and an SEC1. Have you seen what those sell for these days? Wow, no. Stuff has just gotten insane recently. It's really bad. I hate thinking about the value of the computer stuff that I get. But on the other hand, I kind of have to think about the value of these things when I decide to spend the money on them. Usually I get really good deals on the stuff, so it's not that big of a concern. But then, you know, maybe I'm gonna like stretch myself a little thin on a purchase, but then I'll think about it more. But I don't sell anything. I've actually never sold a vintage computer part, ever. Which is gonna seem really weird to a lot of people, but I haven't. I've given some away, but I've never sold any. So the value for resale doesn't matter to me. It's just the value of acquisition, and whether or not I'm gonna regret not getting it sooner or later. So yeah, but I do think about like I will spend as much money as I can on vintage computer hardware because I know they appreciate, but I don't like to think of them as investments. So yeah, why don't you sell? Too much hassle? Well, for one, the way I perceive making videos is that once something is introduced on the channel, it is canon to the YouTube channel. I have to always be able to refer back to it. So even if there's something like created product keys here, like I'm never actually going to use this again regularly, but this is something that, as far as I'm concerned, I need to have access to because it's been on the channel and someone might ask a question or want to know more information about it. and I have it. So that's a thing that stays here permanently now. Even if that becomes worth like $1,000 for some insane reason, I'm never going to sell it. And I feel that way about everything, is that every single thing that has been on the channel is core to it and won't be removed unless there's a very good reason. Like maybe there's a part that I have for the IMSI stuff because I got extras that someone else could actually use to get their system working and there are none available. I would be open to donating it to them. I'm not really going to sell it because that stuff is ridiculously expensive. So I would rather just help them out that way. But generally, no, I don't want to get rid of stuff, and I'm not looking to like extract value from these things. I really hate how expensive all this has become, and it just, So yeah. So let's see. I'm surprised no one has come out with an ISA or PCI MPU 401 card. So Hiram, look up the PC MIDI card, just PC-MIDI. It's an 8-bit ISA card by, I believe, Sergey. And I have one in my 46 PC. It's how I interface my Roland stuff. It's just an MPU 401 card, period, dedicated, straight up. It also has wavetable, so you can put that kind of stuff on there. And it's just that. It doesn't do anything else. So they do exist. I don't know about PCI. That's a little trickier. So I don't know what your luck will be like there, but yeah. PC-MIDI, yes, Hiram, that's it. Let's see. Back when I had a larger retro PC collection, I did fair trades. I just did fair trades, only sold it when I needed to move. Collections in good hands, and I needed the money to start a new life. Yeah, I can understand that. Like I would only consider a wholesale selling if I was going to do anything like that, but I don't even think that would happen. So, yeah. Never sold any of my collection so far, but will do to free up some room. I have donated to a computer museum though. Yeah, I'm hesitant to say I would donate to a computer museum because if they were like, oh, what do you have? Like, oh, I have a Data General Model 4. It'd be like, well, we want that. So that's not likely to happen. I'm honestly more likely to start a computer museum than I am to sell stuff. So yeah. Collecting vintage computers has gotten to a point where it's hard for my generation to afford them. Start a collection. Yes. I'm closer to your age than you may realize. So I agree with you. Almost all of this hardware is new to me. And it's just been lucky acquisitions. That's the way you have to do it, is you have to look all the time, constantly. Like multiple times a day, I run through a dozen Craigslist searches. If I was really, didn't hate Facebook so much, I would use Facebook and look on Marketplace for that kind of stuff. Certishop, yeah, I think that's it actually. My mouse fell down. I have the trackpad, let's use that. Let me see. Would you lease or lend it though? Absolutely not, that's even worse. That is it, Hiram, that's absolutely it. Leasing or lending this kind of stuff is a big problem because unless you're there, you don't know how they're going to treat it. And they may not understand, like, oh, the IBM CGA monitor has phenomenally brittle plastic, and if you put it down even slightly hard at the wrong angle, you're going to shatter the thing. And then you'll get it back, and they won't have known that, and they broke it. And they're like, oh, it broke. Good thing you have insurance, haha. And it's like, well, it's not just that. It's actually hard to get those. So... I even value aside, I just don't want this stuff to get damaged, and unless I'm the one doing that kind of thing, I wouldn't do it. And honestly, the money is not worth it. How much are they really going to pay me to do that? I mean, it's just not worth it to me. I know there's like 2 routes people go when they do a bunch of like a large collection like this. Well, now 3 routes. There are prop people who will lease this stuff out, and usually they have a source for large quantities of stuff. They either go to auctions for like old school clearance or government stuff, and they'll get like a bunch of things all at once, which is what you really need to lay out to provide content for a set. Like they want to do a whole classroom of a particular thing. They're going to need a lot, so you're going to need bulk. So there's that route where you go to the prop warehouse, and I know of multiple people who do that. And then there is the museum, where you think you're going to open a museum and have people come tour. Usually not too familiar with people who actually make it to the museum territory. I know there's a lot of small independent museums And that's why I never have really said that I'm going to open a museum. I think that that's a lofty goal, and that if you're going to try for that, you need to have an actual plan and rent real estate for it, which is complicated, I can tell you. So there's that. And then there's the way that I'm going, where you get a collection, you do YouTube videos. And usually you do that in your house. I'm now an anomaly in doing it in a leased space like RMC is. So that is interesting, but I could, although RMC almost has a museum since he has people over, I could theoretically do that, but I'm not set up in a way to do that because I'm filming in the main space. He has a lot more space than I do, I can tell you that. Space is at a premium where I am. So let's see, I dumpster dive at work where there is a lot of ancient stuff still in use. Ooh, that's nice. Like the PDP that's still, whoa, that's incredible. Here in Seattle, we lost Living Computer Museum after Paul Allen's death. Oh, that sucks. Man. So that's how I got my VT220. Ooh, nice. Speaking of dumpster diving, I saw a thrown out CRT, heard a bit to see it. I have, there's some, I don't know why they are there, but there are like these dumpsters in a Walmart parking lot nearby me. And I drive by them every now and then because people will just leave CRTs by them. And I have rescued like 3 monstrously big, like Wega class CRTs from there. It's hilarious. Ah. See, I just noticed. A shot looks like some screenshot from a TV show or photo magazine. Are you talking about the way I have this laid out? I have very carefully framed this shot, but it's not quite like magazine-like, but it is very curated to have how this shot is. Yeah, I've tried to set this up as best I can. I could do a little better, but for having everything be flexible, this is about it. I do actually have fixed lighting for this set, so it's kind of interesting. Like I've done this before where I've just turned off the lights here. All of the lights for this space, I don't ever move for anything else, which is kind of awesome. I just come in here, I flip the one switch, and all the lights turn on for this whole area. It's become really great. We should probably do more work like it's actually useful here instead of just, you know, sitting around chatting. Let's see. Let's try a 200 milliamp, which means that I should set this to like 50 milliamps. Let's try that. So if I do I set 0.05, this should be 150. Perfect. You can't see that. Let's do this. So I set this to, I wanted 150, so I'd know I'd be less than the power supply I'm about to put on there. And because it has a 100 millivolt offset, or 100 milliamp offset, that worked. So, okay. Let's see. Yeah, I've never had much opportunity to dumpster dive stuff. I've never been in a place where that's really like a thing. So I don't have any stories like that, really. Let's see, for 36 TV, lots of inputs. Years ago, the image started squeezing together. Hiram, it's definitely vertical deflection. Probably a capacitor not fully charging up. If it is uniformly squeezing down, it'll be a cap right before the vertical deflection, the V-sync, that goes to the CRT. So if you can find a schematic for it, you could try and figure that out. And if you can't find a schematic for it, what you should look for is go to the CRT where the vertical deflection is. You're gonna have to look up what that'll look like for your specific TV, and then trace the wire back and then probe your way back from there based on the traces and look for caps that are nearby it that work. Because the way that the vertical deflection on a CRT works is, and I kind of showed this in the Killer Poke video, you have a cap that'll charge up to a specific, well, the way that actually works is that cap is like nearly instantly charged up, and then it is slowly discharged, and that slow discharge controls how fast the beam moves down. And if that cap doesn't fully charge up, like with the Killer Poke, where it shunts the current somewhere partially, so the cap doesn't fully charge. You end up squeezing the image down. So is your image like it's stretched up at the top and then kind of crunched down at the bottom? Because if it's like that, then it's almost certainly your vertical deflection is not charging up fully. So yeah, something to look into. Okay. So I'm plugging in this. This is output DC 12 volt, 200 milliamp, positive center. So if I turn this back on so I can check the voltage, grab this. Positive. Negative 18 volts. Well, it's linear, makes sense. So that's a thing about linear power supplies like this. It's actually high voltage because it's assuming there will be a load, and then it'll come down as the load happens. So let's put a load on it. This is set for, well, it's not really 12 volts, but it'll draw 150 milliamps. So let's try this. So I'm gonna swap out the positive connector here. So there's that. So this will be positive side, and this will be negative, and I will just tap that, and we'll see what we get over here. Let me turn the light back on. Will that actually help? Ooh, it did help. Pull this aside. Now you can actually see. Okay, so positive goes to the short side. And negative goes over here. This should draw 150 milliamps. And it did at about 12 volts. Okay, finally. Geez. We got somewhere. Cool. That's actually working. All right. That's a real load test. Let me get the probe clips on there for the oscilloscope, and we can get a fancier reading of how this is handling the voltage drop. So positive there. Clip the probe, and actually I can use the negative to possibly hold the banana jack in. Boom, and then perfect. Okay, now we're actually clipped onto here. So we're drawing 150 milliamps, and we are getting 12.5 volts. That's pretty good. So there's that. Let's move this around. Is that not working? Why is that not working? Okay, there's our thing. Ooh, that's interesting. Trigger's really soft. Auto. It's real jittery too. Let's see. Whoa, whoa. Thank you for the 586 bits, Valiant Steed. And no problem. I'm having fun here. I'm glad we're doing it. Oh, I earned a new bit badge. Oh, okay. I see how it goes. I need to get those done with something that'll be like actually fun to use. So that's interesting. Linear power supply here has a lot of voltage swing. So that's 2 volts per 0.2 volts per division. So we're getting like half a volt, nearly 3/4 of a volt swing. Whoa. Let's see, just now I wonder how one would use the other power supply without the ability to set the current. Oh, Red Sheep Gaming, hello, since it's first time chatting. Maybe it has bad filter caps. So this is a linear power supply. So I think what it is that it's just like a rectifier, and then this is the like there's probably no caps in there at all actually. I don't know what the regulation is. It's only 200 milliamps. So actually 150 milliamps is kind of high. Let's do, I set, like 10 milliamps because it's not able to do that. Let's do that. Okay. Lower current draw, 100 milliamps, which is half of what it's rated for. We pretty significantly reduced the ripple there. So you know what? I'm going to do 200 milliamps as the thing. So let's draw full current. Boom. Okay. That's pretty high ripple. We're 11 volts. I'm going to get a little sketchy here. I'm going to draw 250 milliamps, and the voltage is going to shoot down. It might reach like 10, and then the ripple is going to go crazy. So I set 0.15. Boom. Ripple crazy. Nearly 10 volts. And it's less so that it can't deliver that current. It's that it can't deliver that current at that voltage. So I wouldn't be too surprised if it could be the exact same model with a different sticker on it that says it's a 10 volt power supply at 250 milliamps. So, see, let's go back to 150 though. So that's good. Okay, let's try a 300 milliamp power supply. This is 350, also linear. Should be interesting. See, linear power supplies have filter caps as well. Maybe, yeah, probably. It should, yeah. All right, let's try 350. See what it's like. Hopefully better. This is a garbage power supply. No idea what it's even from. So it's I intentionally picked some bad ones. And then after this one, we'll try another switch mode. See how it handles. So let's see. Red Sheep Gaming, what have I missed? Just got home from work. Honestly, I should put the category for this stream to just talking for how much actual work we've done. I haven't missed a whole lot. The premise of what we're doing here is that the HP power supply I have right here can sink current as well as source it. It is a 2-quadrant power supply is the term. And I'm just trying that out and getting familiar with how it works. So that's basically all I'm doing right now. So you haven't missed much. I'm just kind of messing around with this, getting comfortable with the process and seeing how it responds to things. So this isn't working. Why is it not working? Let me plug this in a little. Oh, you know what? It might have like a really huge center pin that won't connect. No, it's actually connecting. Okay, weird. Make sure. Negative sides connected. Plug it in. That power supply may not work. Okay, let's try a different one. So, Shelby, I've seen you've seen Solid Green. I have not seen it. I'm not a really big horror movie fan, so I'm familiar with the premise, though. See, is there an isolator on the scope, or is he leaving ground lead off? So these are ungrounded power supplies. It's not horror, it's dystopian future. All right. I haven't seen it partially because of the cover, which feels very horror. But yeah, maybe it's not. But I am familiar with the premise. See, I love watching tour streams. They're great for, or I mean, your streams great for passing the time while playing that. See, Solid Green also has, oh, interesting. Oh, gosh, that's gross. That's bad. Auto mod blocked that one. Okay. There's some colorful people on Twitch, it seems. You also have computer space. Ooh, wow, that is cool. All right, let's try this. Boom. Boom. That one's not working either. Why? Well, this is now switch mode power supply. Oh my gosh, I'm an idiot. I had it offset. There we go. Boom. Okay. Now we're getting some stuff. That is some weird stuff. 9 volt, 150 milliamp. Whoa. I don't think this is, well, you know, we can just use the, let's do this. Continuity test here. Let's answer the question if this is grounded. I don't think it is. I'm pretty sure it's isolated, but we'll see. So continuity, boop, okay. Negative outside, not grounded. So I'm good. Both are disconnected from the thing. I don't have to worry about blowing up the scope. No direct path. See, how's it going? Actually managed to catch some of your stream while at work. Ah, cool. I am also, hello, Critically 93, since it's your first time chatting. Man, bunch of people here all at once. Watch out, some of those wall warts are not isolated. Will tie hopefully the neutral to AC. So yes, this one is good. See. Can I learn electronics just by playing with simulators? You can do pretty good at that critically. I would a better simulator for it would be like Spice. Nowadays you might probably use P-Spice, but that's one that would definitely work. You would have to learn some pretty fundamental stuff to figure it out, but you can learn some good stuff. I don't know if something like Fritzing has a Spice emulator type thing built in, but that could be a way to go. Because actual P-Spice is a little complicated. Get it going. Let's see. After all that happened in the last year, Solar Green doesn't feel that dystopian anymore? Yeah, really. I am familiar with the premise. Just haven't seen it. That's not really my kind of bag of movie overall. Okay. So this is the weird switch mode power supply. It hasn't done what I would have thought. Let's see. Also, Brian, I'll catch you in here. So, because this is definitely more in your wheelhouse, too. My HP power supply here is a 2-quadrant power supply, which is the terminology for electrical engineering power supplies specifically. But it can sync current, and I am doing, and I'm currently syncing 150 milliamps on this display, but it's only showing up as 50 milliamps here, which is weird, because I just did a linear power supply, and those two agreed, but whatever. So I'm just getting familiar with how this process works on this, because things like this are acting weird. And I'm just trying to know what to expect when I do this for real. Because a lot of people use like a dim bulb test for this, where they'll create a load test out of automotive bulbs that are like 12 volts DC. But I have this, and I bought this specifically for this reason. It's actually kind of funny. This is one of those things where I knew this before I put it in my eBay search history. That's how I got this, was eBay. And I kind of forgot by the time I bought it. And I was reading the manual, like, wait, this thing can sync currents too. Oh. But yeah, I'll frequently put something in my eBay searches, and when I find out about why they're really cool, and then I'll forget later on. So, yeah. But this is a current syncing power supply. So I don't know, I don't like how low the voltage is dropping and how much ripple there is up here. This is 1 volt per division, 5 volts per division. Now it's 5 volts of ripple. That is a 10 volt ripple on there? That does not make sense. What gives? Let me set to 0, enter. Okay, it gets even more unstable. Oh, maybe it needs more current draw to stabilize. Okay, let's do set, not 4 amps, it's not a 4 amp power supply, 0.4 for half an amp. Okay, we're drawing half an amp, but it's down to 2 volts. What? That doesn't make sense. Maybe it's just bad. I could explain it. Huh. See, if Electroboom can't blow up a scope, then I doubt you can. I bet if you tried, you could. Let's see. Came across breadboard simulator for the classic Macs the other day. Ooh, that's not quite what they're talking about, I believe, but that's pretty cool. See, every circuit is a fun simulator if you're into those. Okay, that might be good. Spice is literally command line, like meant to run on, like, probably data generals have actually run Spice. I wouldn't be too surprised. Not those, but some. Yeah, Spice is old, really cool. Interesting possible accuracy issue. So that's quite interesting. You can sync current with the power supply. Never seen or heard of that before. It is a special kind of power supply. I actually have one back here that is a 3-quadrant power supply, which means that it can also do negative voltage. I think this thing just shut off. I'm gonna unplug it. I think it's cranky. I'm guessing this thing is bad. Let's try a different one. So here's a different, pretty sure switch mode. 0.4 amps. No, it's 1 amp again. And it is positive center. But yeah, it's a combination power supply load tester, electronic load, which is super handy for electrical engineering. I got to use electronic loads in a former job. When you have a need for it, it's really nice. And since I want to be able to qualify power supplies here, it'll be really nice. So that was part of the reason why I picked this, but yeah, it's going to be, I'm just trying to get familiar with how it works on this, because this is not a discrete load tester, it's an integrated thing, so it's a little weird. I set 0.1, so we should draw 200 milliamps. Let's give this a shot. Boom. That's perfect. Okay, this power supply just sucks. It's just garbage. Get it out of here. Because that's perfect. That's exactly what I'm looking for. So we can see 12 volts, 200 milliamps. Boom. Okay. Being able to sync current, I'm presuming you need another supply to actually supply power and using it to sync current. Yeah, so what I'm doing here is I'm using just generic wall warts, and I'm doing a load test on those right now is what I'm actually doing. So I'm load testing as a 12 volt, 1 amp power supply, and we can see it's 12 volts, 1 amp, right, or 0.2 amps, because that's what I'm drawing. And it's negative because it is power supply first, but it can sync as well. So, let's see. Red Sheep, we wouldn't get mad. It's just not really what this place is for. So, but yeah. Let's see. So this is cool. So another thing I'm trying to do here is check ripple current, just to get familiar with that process. So that is, we're at 20 millivolts per division, and it's kind of messy. That straightens it out a little bit here. That's super faint. Lots of weird things going on in that signal. Wow, that is interesting. Look at that. That's kind of crazy. I mean, we could definitely see the switch mode-ness working in there. But then it's got some other filtering. This is a complicated little power supply. I like that thing. Let me change the load. So we're at 0.2. Okay, I'm going to drop it to, I set 0. So 100 milliamps. Boom. Okay, the load changed. Interesting. Ooh, this is cool. I'm going to bump up the load to half an amp. 0.4. Boom. And it gets even messier, but it's actually kind of staying pretty good. Like there's a lot in there, but it's not getting out of control. So this is 50, hold on, that's 50 millivolts per division. This thing's doing pretty good actually then. Let's go with, can we do that? And then can I trigger on, there we go. So that is 50 millivolts per division. We have like barely little spikes coming out. So that's 150 millivolts. That's not, okay, maybe that's not great. But I feel like it's not bad because the central core of it is in there. That's a rough signal. Makes sense, it gets messier as load increases, yeah. I don't know, I'm not sure if I think this is a really, oh, there we go. Now we can see there's some pretty significant spikes in there. But they're small, they're insignificant, and they get loaded down quickly. So another thing is that this has, I assume, no input capacitance. If I put a capacitor on this, it might smooth it out quite a bit, actually. So let me just try with this 100 UF Rubicon here real quick, like, see what that does. So, boom. Yeah, input, output, completely smooth, like, totally, as soon as the cap touches it. So, this is without any filtering at all. Should see wall AC power. AC actually peaks at 170. Yeah. Well, this is mostly for like really sensitive stuff. This will actually matter. Like a chip. This would not be good. We would want to see this at that level. But coming into something that's going to have power filtering afterwards would probably be fine. Let's see. Let's go ahead and leave it like that, though. And I'm going to turn the wick up to, let's see, 0.8 amps. So 0.7, add. That doesn't look any worse, really. The big sweeps, well, that's actually pretty bad. That's 100 millivolts, so that's actually a lot. I've got the intensity cranked up. This is one of the benefits to an analog scope, because we can see these transients here slightly better than you could with a digital scope. It might just miss those because they're so faint, or it'll over-represent them. But yeah, if we really lock in there, we can see that right there. So this is interesting. For sure on the Ripple and powering electronics, yeah. All right, let's do full bore, 1 amp. So I set 0.9, boom. This is maxed out what this thing is meant to deliver. So we're getting ripple of, I bumped it up to 0.2, so we're getting here to there. That's about 5. So we're getting a 1 volt ripple. So that's a thing. I can, you know what, actually, let's try this. This fluke meter can measure AC. So let's do an AC measurement of the ripple voltage and see how bad that is compared to what we're seeing on the scope. So there's that and that. Boom. So it's saying only 2 millivolts. That seems a little light. Oh, all good. Don't worry about it. Just stand went a little far back. And lost syncing connection. 1 moment. There we go. See, it's only saying 3 millivolts. That, not too sure about that. If I crank up the scale. Okay, they're seeing 300. What? 3 or 300. Okay, that's a little strange. Yeah, the camera really does like the GPIP adapter, doesn't it? I wonder if that's like the range. I have a dead zone set on that side because there's no reason for the camera to ever focus past the monitors. So it may just be slamming against the wedge there. So you remember the AC reading on the Fluke will be reading RMS AC voltage. Yes. So that should be the peak to peak voltage. That's what I'm looking for. But it'll be slightly smoothed as well. You will probably have a lot more experience with something like this. How smoothed would that be? Because it'll miss transient stuff like these really big peaks that I'm seeing here. This thing probably can't capture because it's actually really slow. That's one thing that's really funny about these 2 meters in particular, and why I like this one so much more than this one. The 34401A is like super duper fast. It is great for bench stuff. The Fluke has other features that are good, but it's slow. It's really slow. See, hello, Soggy Electric. Ooh, excellent. The stream is still going? Yes. I'm doing power supply testing. See, how warm is that? That's noticeably warm. So I'll fill you in right now. What I'm doing here is, as part of my preparation for capacitor reforming, I want to load test power supplies before I put them on there. So the power supply that I was using to do the actual reforming of the caps can also be used as a load tester. So here you can see we have -1 amps flowing into this. So I have a wall wart over here that I have connected to a whole mess of measurement stuff going on here. And I'm just getting some practice in with measuring the load being drawn from the wall wart and the ripple current, which I'm trying to get here, and just seeing how it works. I've actually identified a bad power supply with this setup, which I wasn't expecting. So I have a power supply I'm going to throw away after the stream because it was sagging the voltage way too much compared to what it's supposed to be able to draw. So I didn't even realize that until just now. This setup just worked, and it identified a bad power supply. TTR, are you going to try the floppy power supply today? No, I'm not. We ended up burning so much time just sitting around chatting. I kind of wanted to try that today, but we did not get to a point where that makes sense. So we're probably just going to fiddle around a little bit more and then end it here, because I didn't work through this as quickly as I thought. And this was kind of always going to be a nice kickback stream. I didn't really have a super solid plan. See, Niceologist just did load testing with a 1 ohm resistor taped to an old CPU heatsink. That looks way more proper. Yeah, that works. A lot of people also do a bulb tester where they'll have a bunch of sockets where they'll put 12-volt automotive light bulbs into and vary the wattage based on which bulbs are in there and which ones are connected. So that's the other more common way of doing it. But I wanted to do it like this. So this is the more electrical engineering type way to do it, and this is the way I'm accustomed to. And I want to just, I don't know, I don't really know how to explain it other than this feels right to me. I'm not saying other ways are wrong. It's just this is the way I want to do it. So, does anyone here have an ADDS mentor? And I definitely don't. I don't have a lot of terminals. The ones I have now, I'm really fascinated by, but I don't have a lot of them. Actually, I think the Televideo 950 might be my first. I called it a mainline terminal in the IMSI video, but it's my, I would consider first like non-clone terminal. So yeah. So sorry for this really obvious question, but how do I redeem byte break? So what you have to do is underneath the send a message thing, there's a little round circle, and it has a number next to it. I think you're new to this stream. I don't know if you've been lurking on other streams, but you need to have 5,000 channel points, which you get just by watching the stream and then clicking the little green box that pops up. Once you have 5,000 points, you should be able to scroll through the options and find byte break and then redeem it that way. So, let's see. The mentor was a computer. Running PIC. Found a hard drive controller for it. Interesting. So, this power supply is still going. This is cool. I like this. Okay, I think I'm happy with this research here, actually. Yeah, that was cool. We identified a bad power supply. I didn't even think about that until just now. Yeah. All right, what next on this setup? Trying to think here. I got that's an unused 12-volt power supply. I think it's a better one too. This is one I actually regularly use for stuff. I'm curious how it responds. Let's see it. So this is a 1.5 amp power supply from Honor, I believe. So let's see what this one looks like. See, what's the temperature on the PSU? It is, it's getting hot. It is getting warm. Or unless you mean the HP. The HP, HP's doing really good. It's not sweating at all with 10 watts of power there. See, what does the 100K mean? Where is the 100K? Oh, what does the 100K one mean? Does it mean, does it make you spend the rest of the stream doing something with a specific computer? It means that a future stream will be dedicated exclusively to that computer. So I will plan a stream just about that one computer. And the intention is that it allows you to like ask questions that maybe I didn't answer in the video or see something specific demonstrated. If you picked that one, I would ask you some more questions like, what do you want to see me do with that computer specifically? And I'm really hoping no one just says like, I just want to see it in use, because then I'm gonna have to like come up with a bunch of like random stuff to do for a couple hours. But it's intended to be so that you can see something specific about that kind of computer. So, see, when you get there, I'm asking for the Micron tower. Brian, I specifically have it stating computers at work. And that one I don't think I've gotten working yet. I haven't replaced the power supply. That's probably all it needs. But yeah, that's, yeah. So running Doom in the Data General is on the table? No, because the Data General doesn't work. See, that's the catch. It has to work. I'm not just going to spend the stream talking about a dead box. So, let's see. Hello, Vivian Comfy. Let's see. See, it will take a regular ATX power supply. Yes. Yeah. Oh, it probably, again, I could probably just walk over there, swap out a different power supply, and have it fire up right away. So it wouldn't be an issue for that one. But yeah, could be an interesting dead box. I mean, the Data General is an interesting dead box, but they're also terrifying because I don't want to ruin them. See, I'm guessing Data General PSUs are big linear units. Centurion PSUs use a ferro resonant transformer, which seems to be fairly common device for stuff that needs dead, stable, reliable power supply. Just heads up, if it's ferro resonant transformer, those things hum quite a bit. I'm not familiar with a ferro resonant type like that. I actually have the power supply for the Micronova out right here. So this is it. I disassembled this in a stream a while ago. I don't know if you'll recognize anything here. So I didn't take this out when you were actually here the first time, because it's kind of like, obviously, here's a thing. I got a giant stamped shield around it, but we can see some stuff. It's not a tremendously large transformer in there, really. So it's kind of down in there. The humongous caps there are going to be my main focus, since I want to reform everything. Yeah, it's mostly the big caps, the single transformer in there that has selectable 250 and 120 volt stuff, and then this, the giant field of power regulation on there. It looks like I should probably just turn the light off. So that I'm hoping I won't have to do too much for. But yeah, let's see. You can usually pick them out by big AC capacitor that's used for the in them. Okay, well, this has 2 huge caps, but that's kind of standard from what I've seen for this old stuff. Is we got 2 giant caps here, but maybe that's it. I'm not sure. I'm really afraid one of them's bad because if we look at the lugs up here, that one's nice and smooth, and then that's actually another one that's a little grungy. So I'm wondering if one of these caps have leaked onto there, or are there any of the battery wires connected to that? Because that would be nice. If it was battery corrosion. That could be it too. Not seeing it. Oh well. But yeah, so I'm not sure from there. This thing is going to be an absolute nightmare to go through and load test, because each of these are a different voltage output. Like, look at the wiring harness coming off of this thing. This is, oh my gosh, this is a nightmare. So that's not going to be fun. The Nova 2 use linear PSU. If your transformers are humming, it probably means that the lacquer holding the plates together is going bad, and they're coming loose and rattling as it runs. So say, ooh, interesting, those big ones will be smoothing caps. Yeah, smaller oval rated like 600 volts. Oh yeah, no, low voltage. Everything in there is low voltage from what I've seen. There's one here. Let's see, what's that? That is 6 volts. Yeah. So no, everything in here. That is 20,000 UF at 6 volts. Yeah. So everything in there is pretty low voltage. I thought it said 2 million at first, but it's just kind of weird font for the U. Yeah. So that is that's that. See, not 6.3 V for the haters or heaters. No, it said 6. It's 6 VDC. So, yeah, it's not 6V3 or anything like that. So, let me try putting the other power supply on here real quick. Like, this one disconnected. Let's, oh man. Pinch that. Okay. Clip that. Boom, and then kind of just tuck that in there. Sort of. I'm a little surprised this whole connector setup's not getting warm with drawing a whole amp. That's a lot. All right, stress out a new power supply. Let's see. We used to dip inductors in a vat of varnish. Yeah, to prevent the core from singing. Yeah, that kind of thing. So a bit of info on the ferro resonant. It's kind of like 2 transformers sharing a single core. One is main one, the other is small one for AC, LC, tanker circuit. They push transformer into saturation, which is why they tend to hum. Okay. Interesting. Okay, so there's that. And then try and get it's connected again. Everything just kind of let go. Thing wants to be a pain. There we go. It's going to be a much better connection this time, though. Got that way more sorted out. All right, go ahead and plug it in. Boom. All right, this is a much better power supply. And it is rock solid there on the ripple. So that's 50 millivolts, so that's like 75 millivolts ripple on 1 amp. And this is a 1.5 amp power supply. So that's way better. And this time this agrees. So that's cool. Let's see. Funny to have to run a hardware math board on a mini computer and wait 5 minutes. Well, thanks. Do you have like a multiply divide board on there? See, well, that's looking good. Let's do 0. I set 0.4 to get half an amp. That's looking good. Yeah, it seems like that's just the ripple it's got is 100 millivolts-ish. Even that 100 millivolts is pretty clean. Ah, cool. That is awesome. I think mine doesn't need that. I thought I wanted one for a while, but I think it actually just doesn't benefit from it at all. Or can't use it, so yeah. Now, so this is higher current output, so let's try maxing this one out, 1.5 amps. So I set 1.4, boop. There we go. Oh, it's actually even more stable. Seriously? That's cool. Yeah, it just is. Look at that. And drops over to millivolts. I don't know why that's still reading so high. That looks more like 25 millivolts ripple to me. Huh. Because that's a single division there. It's like barely under it. I think that one is good. Yeah, this is a really good power supply. That's kind of what I said. This is a better one than actually is more of a go-to one I've used frequently. And it's not garbage. Like this is not what I would consider a good power supply. Green SPS switching adapter. That's what that one is called. So that's nice to see. I like this. This is really cool to be able to actually check this stuff and test it like this. I like this a lot. See, kudos to rocking the BK Precision Linear scope. I've got an older 2120B. 20 megahertz is my daily driver. Yeah, I think this one is 20, or is it 30? Oh, it's 30, okay. Yeah, I use this one for when I want to see quick things. And then I have an HP 16500C logic analysis mainframe craziness whatever thing. That's like the complete opposite of this. This is boom, 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 get work done quick now. And that's the one I go to for this kind of thing. But then when I want to do something fancy, I use the other one. See, analog, yeah. Oh, I thought for a second you were talking about my power supply, which is a BK Precision linear power supply. So I finished what you were reading, yeah, or what you wrote. See, I only have it so I don't have to wait 5 hours for it to calculate 100 digits of pi. Yeah, yeah, that will help a lot for that. Well, this has definitely been an enlightening test here. It's kind of cool. This is both easier to use and more complicated, but I think it was mostly complicated because the power supply was bad. And it's really good that we had a bad power supply because now I know what that looks like. And the voltage will just sag a ton, which, you know, that's what it should have done. I just figured I had this set up wrong somehow, but no, that was it. Huh. Oh, so I can see voltage is down to 11 volts on this thing. Let me try, I'm gonna set it to half an amp and see if the voltage jumps up. Just a little bit. Ripple's really good now too though. That's weird. Let's go an amp again, because I was in the middle where it was not as great. Oh, interesting. Maybe it just needed to warm up and it's settled into being more efficient now. Huh. See, yeah. it's the data general stuff up on a wiki somewhere, caps wiki. I don't know how to search it properly there. So I do have, I'll go ahead and link it in chat because it's a little weird. I haven't created a proper caps wiki entry page for it yet. What I've done so far, is go to my user page and then start putting some stuff there under a projects section. So I have it, where's my chat? Here. So you can go to that and then find some of the information that I've cataloged so far on them. I haven't started doing any diagnostic troubleshooting yet, at all, none. So I'm going into this assuming they, well, I really don't know what to think. They probably work. I don't know. It's just, I'm trying to take it slow, figure stuff out as I go along. Yeah, no problem. That has the boards that are in my Micronova, because I'm starting with a Micronova, because of the two, if I screw something up royally and toast a Micronova, I will cry less about that, and it's more likely to have chips that are less bespoke. So that's part of why I'm starting with that. Yeah, I need to start figuring out what things are like ROMs and try and dump those so they can be saved and stuff like that. But yeah, I'm not really sure what the next steps on that are going to be. Probably taking out the caps on the power supply and then just trying to fire it up, see what happens. You know, well, reforming it, of course, first, and then trying to fire it up. But I got to figure out what the actual the power outputs are, because it's kind of crazy. So I want a place to put some of my old radios in there once I get to those. Yeah, if you're working on those, that's fine. See, if my experience is anything to go by, I expect about 90% to work brilliantly, the remaining 10% I'll be ripping hair out. Yeah, probably. I'm afraid of what the custom chips are going to be like in there, because this is much older stuff. And those types of things tend to be more difficult. But hopefully there's some cross-reference material available if it's out there, what custom chips are actually just rebranded other things, because I don't know that there's too much in there that'll be actually data general custom. So, yeah. I think I've done everything I can for testing the current syncing capability here. I feel like that just worked, and it's gone well. So let's see. Sorry if I'm asking obvious questions, but stream points carry over. They carry over from each stream. Yeah, so you can build up a lot of them. Like I have over 100,000 stream points on someone else's channel. So yeah. Test more power supplies. I haven't tested like a bunch of different power supplies. I kind of just wanted to get a rough idea of how it worked. I don't know how many more power supplies. I'd have to go grab like a bunch of them, and it's slightly fiddly to do this. If I had an easier way where I could just swap out a bunch of different barrel jack power supplies, I would do it, but it seems like every time I do it, I have to spend 3 minutes getting all the connectors lined back up here. But I feel like I've learned the majority of what I need to here, in that when I go to actually load test the 8-inch floppy drive power supply, probably, I think I'll be able to. So I don't think it's going to be a big problem. Could we see what the PSU from the Micron does? That actually would be really interesting. I would like to see what that does when we load down the different rails, because that's another thing. Part of why I've been wanting load testers is I really want to be able to load test an ATX power supply, but I absolutely can't with what I have right now, because they output so much power. Like if I was going to, I think 400 watts total would be a good place to start for ATX power supplies, because I want old stuff. I don't care about the new stuff. So that would be a good one, that would a range that would cover everything. But then the problem is that you have different rails on there, and each rail adds up, and I don't know how many discrete 5-volt rails there are per se. So I would have to measure each one individually, but then if maybe it's a really weird power supply and it's more, I don't know. I just have to, it's kind of a pain, because I bet most 1995 and newer ATX power supplies could deliver more than 2 amps on their 5-volt rails. I bet they can. Or even their 12-volt rails. And 2 amps is like the max that I can go on this power supply. I think maybe 4 amps on that one. Let me double check. This is a second. 66 series power supply. This one is 5 amps. Oh, that's actually pretty good. That can be used on 5 or 12 volt rails. So that one's actually much better suited to PC stuff. Try 20 amps. See, that's the thing. At Hellencroft, I'm not sure if that's a rail or total for all 5 or 12 volt sources, because yeah, that's the thing. See, for old 400 watt would be overkill. The supplies typically have per rail voltage limits. Yeah. You still have time to test the Threadripper stuff? So Evil Warthog, I don't have any water cooling parts. That's I wish I did, but I have really no way of actually testing it because I have to run water through it, and I don't have any of that. I actually put some stuff on my Amazon wish list to get, because I'm gonna have to buy a lot of water cooling hardware to get that thing going. So I want to test it, I can't right now. So that's all. I do have the power supply for it. I have a 1000 watt EVGA power supply that should be perfectly suited for that. So once I get some water cooling hardware, I will be able to do it. So yeah, see, I love reading the 4X service data with it constantly. Been like, let's just replace the whole board when this chip is bad. Yeah. Are you looking at my stuff service history? Because it's kind of bananas. Yeah. Let's see. Yeah, you guys got it there, because this stuff, it's really hard to test ATX power supplies with load tests. That's why Gamers Nexus, for their like fancy pants modern power supply tester, it's like an $8,000 device to be able to do it. So yeah. I wish I could test that stuff, but I definitely can't do that anytime soon. So well, yeah, I think we should probably wrap this up. I definitely feel like I've accomplished my goal, and I'm happy with the results we've gotten from that, because it was really cool to see the power supply be dead that I checked there. So I was not expecting to identify that today at all, but I feel pretty confidently we did. Now I'm going to get to chuck that thing and reclaim my hook and loop strap, so that'll be nice. But yeah, so I guess we'll run the outro, and this will be a sub 4-hour stream, which is a little less wrecking to me. So yeah, okay. Well, all right. It feels like the stream's ending abruptly, but kind of really had a very simple goal here. Didn't really have a whole lot to it. I wanted this to be a laid-back stream, and I think it was. We had some really good time here today. You guys absolutely blew me away at the beginning there. Thank you all so much. That was, yeah, it was a lot to take in. In so much, in so many ways. So I'm really appreciative. But yeah, we have had a good time today. We verified some stuff. Actually, I should probably unplug and all this stuff so I don't forget, because it's just running so smooth there. But yeah, we tested the ability to load test power supplies, and that worked phenomenally. I look forward to doing that with the floppy drive power supply. I plan on getting to that once I have the 50-pin adapter for this thing, so that I can actually go through and do it, because as soon as I load test it, we're gonna want to use it. So we're gonna load test and then pop this onto it and try and make it do stuff, because the thing is that once I turn on the floppy drives, they're not gonna do anything without a computer connected to them. So it makes sense to wait until we can connect the CryoFlex to the floppy drives before we load test it, because we'll load test it, it'll probably work, and then we'll want to do something, but we can't. So that's not really like a whole stream until that's a thing. So that is it for now. Thank you guys all for hanging out here. If you're watching this on YouTube, you can subscribe to the channel or find the link in the description to hop on over to Twitch to catch the next one live. If you want to help support the channel, you can either sub on Twitch, which you can do for free with a Prime subscription, or find me on Patreon. But that is it for now, and I will see you next time.